Have humans really stopped evolving physically? Or have the pressures that once shaped our bodies simply gone quiet, hidden beneath hospitals, cities, screens, and modern comfort? For most of human history, survival depended on cold, hunger, disease, childbirth, injury, and fear. But today, so many of those brutal filters are softened by technology that it almost looks as if evolution itself has paused. Before we go deeper, take a moment to like the video and subscribe if this is the kind of history and mystery you enjoy. Because once you look closely, the real story is far stranger. The human body may not be finished at all. It may just be changing in ways that are harder than ever to see. The old human story begins in a world that does not care whether anyone survives it. A child is born into cold wind, bad teeth, dirty water, fever, predators in the dark, and the constant possibility that one careless step means a broken bone and a short future. Hunger arrives often, infection arrives faster. Winter strips away the weak without ceremony. Summer brings parasites, spoiled food, and new kinds of risk. For most of human existence, the body is not simply a body, it is a test. It is a wager placed against drought, childbirth, bacteria, frost, exhaustion, and violence. Under those conditions, flesh matters in immediate and merciless ways. A stronger spine, a better immune response, a pelvis that allows survival in childbirth, lungs that endure smoke, skin that handles sun, teeth that hold out longer, a metabolism suited to scarcity, a mind quick enough to fear the right thing at the right moment. None of these are abstract traits. They can become the narrow margin between leaving descendants and disappearing without a trace. Now place that ancient creature inside a very different landscape. The temperature is adjusted with a dial. Darkness is erased with a switch. Food arrives wrapped, labelled, stored, transported across continents. Water comes filtered through pipes. Infection is often held back by soap, antibiotics, vaccines, sterile needles, and people in masks under bright hospital lights. Broken bones are pinned, weak hearts are monitored, eyes are corrected with glass and laser, pain is managed. Birth, once one of the most dangerous moments in the whole human story, is increasingly watched by technology, skill, and emergency intervention. The modern body still ages, still fails, still carries all the old vulnerabilities written into its tissues, but it moves through a world layered with buffers. It is cushioned, stabilized, insulated from many of the pressures that once shaped it with brutal efficiency. That contrast lies behind a claim that appears simple on the surface and slippery underneath, that humans have stopped evolving physically. The phrase turns up in popular science, in casual conversation, in worried commentary about comfort, medicine, weakness, modernity, and the future. It sounds bold enough to be memorable. It also sounds plausible in a way that invites immediate agreement. If the weak are no longer removed in large numbers, if the sick survive, if technology does the heavy lifting, if culture rewrites the rules faster than genes can follow, then perhaps the body is no longer being forced to change. Perhaps natural selection, at least in the old visible sense, has gone quiet. Perhaps the great sculpting pressures of human prehistory have been blunted to the point that anatomy itself has entered a kind of pause. But the moment the idea is held still for inspection, it becomes stranger. Human beings are not statues, they are populations. Populations do not freeze merely because life becomes more comfortable in some places and more technologically managed in others. They continue to reproduce, migrate, mix, suffer, adapt, and die under conditions that are never quite uniform. Even in a world of hospitals and algorithms, bodies still encounter disease, pollution, malnutrition, infertility, stress, heat, chemicals, sleep disruption, and social inequality. Some pressures vanish, others arrive in disguise. Some are reduced in one country and sharpened in another. Some affect survival less than they once did, but influence reproduction, development, or long-term health in subtler ways. Scholars still debate how much modern medicine and culture have altered the old mechanisms of selection, because the evidence remains incomplete and no single explanation fully accounts for the complexity of the present. What makes the question so compelling is not simply whether evolution has stopped. It is that the answer touches a deeper unease. Modern humans live surrounded by inventions so effective that they sometimes feel like replacements for biology itself. Cold weather no longer demands fur because there is insulation. Darkness no longer rewards eyes adapted to starlight because there is electric light. Distance no longer requires exceptional endurance because there are engines. Weak vision does not end a life. It is corrected. Missing teeth are replaced. A difficult birth that would once have killed mother, child, or both may now be survived. In one sense, this is an extraordinary triumph. In another, it creates the impression that the body has fallen behind its own creations, that the species now persists less because of what it has become biologically, and more because of the world it has built around itself. There is truth in that impression, but only if it is handled carefully. Humans have always altered their own selective environment. Even before cities, pharmaceuticals, and climate control, there is fire. There are stone tools. There are hides sewn into clothing. There are shelters raised against wind. There is the sharing of food, the tending of wounds, the carrying of the injured, the collective memory of plants, seasons, and paths. From a very early point, human survival is already part biological endurance and part cultural invention. The species does not wait passively for evolution to shape a better body. It begins, as early humans begin almost everything, by changing the conditions around that body. This matters because the present is not a complete break from the past. It is an intensification of a much older pattern. Human beings survive not only by adapting to environments, but by constructing environments that alter what adaptation even means. And yet the scale of the modern shift is difficult to overstate. In many prehistoric settings, natural selection works with savage clarity. Those who cannot digest local food, resist local pathogens, endure local climate, or survive local labour simply face lower odds of living long enough to reproduce. Infant mortality is devastating. Childhood disease cuts through entire communities. Mothers die in childbirth. Minor infections become fatal. A failed harvest becomes a population crisis. The body is exposed to direct consequences. In much of the modern world, many of those consequences are delayed, deflected, or distributed across systems. A person born with a trait that would once have sharply limited survival may now live a long life and have children. The body is still imperfect, but society catches it when earlier landscapes would not. From this comes a seductive image of evolution switched off, like some ancient machine no longer needed. It is easy to see why the idea spreads. The most obvious forms of physical filtering seem weaker. The modern office worker does not need the limb strength of a hunter crossing broken ground. The modern city dweller does not need thick body hair against winter. A person can survive with severe nearsightedness, poor teeth, a compromised immune system, a narrow pelvis, or a metabolism that would have struggled in repeated famine. Modern life appears to preserve bodies that earlier periods would have culled, and from that observation many people jump to a conclusion: if nearly everyone survives, then evolution must have ended. But even the word survive deserves suspicion. Survival alone is not the full engine of evolution. Reproduction matters, timing matters, fertility matters, child survival matters. So do disease exposure, partner choice, migration patterns, family size, and the unequal distribution of environmental burdens. The person protected by medicine is still living inside a body that interacts with countless pressures, some ancient, some newly manufactured. What survives in the record suggests that when one set of pressures relaxes, another often emerges. The body may no longer be shaped so visibly by predators and frostbite in industrial societies, yet it may be encountering selection through metabolism, immune regulation, or developmental stress in ways that are harder to watch without genetics, epidemiology, and long-time scales. There is another reason the claim feels convincing. Human anatomy itself often looks unfinished, even badly designed, as though evolution has abandoned the work. Wisdom teeth crowd jaws that have become too small. Backs ache under a spine never fully optimized for chairs. Concrete and long hours of sitting. Knees fail. Birth remains difficult because the demands of upright walking and large-brained infants have never been fully reconciled. Eyes drift toward myopia in environments saturated with near work and artificial light. Obesity, diabetes, and cardiovascular disease spread through food systems and daily routines that do not match the older settings in which the species evolved. All of this can feel like evidence of a body stranded by history, a Paleolithic inheritance stumbling through a technological age too fast for genes to follow. That image is powerful, but it is not the same as stasis. It may instead point to mismatch. A mismatch is not proof that evolution has ceased. It is proof that environments can change faster than anatomy. The human body is full of compromises laid down over immense spans of time. It is not built from scratch for every new century. It carries solutions to older problems, and those solutions often become awkward when the context changes. The neck that balances a head over a moving body is not ideal for staring down at glowing rectangles for hours. The appetite mechanisms shaped under scarcity do not perform gracefully inside landscapes of constant abundance. The stress response built for short danger can become corrosive under endless low-level strain. None of this shows that evolution has stopped. It shows that the body and the world it inhabits are no longer moving at the same speed. That is the deeper mystery at the center of the modern human condition. People look almost the same as their recent ancestors. The species does not appear to be sprouting obvious new limbs, thicker bones, or dramatically different faces under the pressure of city life. A person from thousands of years ago, placed in present-day clothing and given time to learn the language, might pass surprisingly well in a crowd. The continuity is real. It tempts the mind toward the idea of a finished form. But finished is not the language evolution recognizes. There is no final version of a species, no moment when nature declares the design complete. There are only temporary fits between bodies and worlds, some better, some worse, some hidden beneath habits and institutions that make vulnerability less visible than it once was. And perhaps that is where the subject becomes most unsettling. If humans really had stopped evolving physically, it would suggest that culture has overwhelmed biology so completely that the old natural processes scarcely matter anymore. But if humans have not stopped, if evolution continues quietly under the surface, then the species is still being shaped, only not in the dramatic prehistoric style people expect. The change may be statistical rather than cinematic. It may happen through gene frequencies, not obvious new anatomy. It may occur in fertility, immunity, development, and tolerance, not through heroic improvements in strength or speed. The old story of human evolution, full of exposed bodies on dangerous ground, may not be over. It may simply have moved indoors, into hospitals, supply chains, screens, laboratories, and the intimate, invisible negotiations between genes and modern life. So the question is not whether ancient humans were evolving and modern humans are not. The better question is what kind of world once shaped the body openly, what kind of world shapes it now, and why the change is easy to miss. To understand why so many scientists and commentators have entertained the idea that physical evolution has slowed, paused, or become irrelevant, it is necessary to return to first principles and then to long stretches of human time, because the body that now rides elevators, swallows antibiotics, survives caesarean sections, and orders food from across a city is still the descendant of creatures who made it through ice, famine, infection, and fear with almost nothing between themselves and the forces that selected them. That older filter has not vanished from the story, but it no longer acts alone, and perhaps has not for a very long time. Before we go deeper, take a moment to like the video and subscribe. If this is the kind of history and mystery you enjoy, the question ahead is larger than it first appears. It is not only about whether human bodies are still changing, it is about what evolution means in a species that has learned, unevenly and imperfectly, to shield itself from so much of the world that once shaped it, somewhere between the prehistoric wound and the modern operating room, between the winter campfire and the climate-controlled apartment, between the raw test of survival and the managed systems of civilization. The old rules begin to blur, and once they blur, the human body becomes harder to read, not fixed, not finished, but hidden inside conditions unlike any it has ever known before. The first difficulty in saying that humans have stopped evolving is that evolution itself is often imagined in the wrong shape. People expect it to look dramatic. They expect claws, taller bodies, larger skulls, stranger faces, perhaps some obvious anatomical transformation visible across a few generations. They imagine evolution as a procession of forms, each clearly different from the one before, as if the whole process were staged for easy human recognition. But that is not how it usually works, and certainly not how it works in a species that measures time in decades, while evolution measures it in generations spread across populations. The visible body is only the most obvious place to look, and not always the most revealing. A population can continue evolving even when no one notices anything startling in the mirror. At its simplest, evolution means that inherited traits become more or less common over time. That is all. No purpose is built into it. No direction is guaranteed. It does not strive toward perfection, intelligence, strength, or moral worth. It does not care whether a trait seems admirable, attractive, or fair. It only describes what happens when some inherited variations are passed on more successfully than others across repeated generations. Sometimes that change is driven by natural selection, with particular traits helping people survive or reproduce more effectively in a given setting. Sometimes it is shaped by sexual selection, in which mate choice and social behavior influence what gets carried forward. Sometimes it's driven by genetic drift, a quieter process in which chance changes the frequencies of traits, especially in smaller populations. Sometimes mutation introduces new variation. Sometimes migration mixes populations that were once separated. The result is not a ladder, it is a shifting field. This matters because the claim that humans have stopped evolving usually rests on a much narrower image. It assumes that evolution is only real when harsh environments kill off large numbers of people and visibly reward stronger bodies. That image captures one powerful part of the story, but not the whole of it. Selection can be intense without being obvious. A trait can spread because it slightly improves resistance to a disease, slightly alters fertility, slightly changes metabolism under a new diet, or slightly affects who has children and when. None of those shifts would necessarily announce themselves in daily life. No one wakes up and sees evolution happening at breakfast. Populations change quietly, and the quietness is precisely what makes modern change easy to misread as no change at all. There is also a deep confusion between individual bodies and populations. An individual person does not evolve during a lifetime. A child grows, matures, ages, gains scars, loses muscle, falls ill, and changes in countless ways. But that is development and experience, not evolution. Evolution belongs to generations. It emerges when certain inherited differences affect what gets passed on. This is why the question cannot be answered by looking at a single era and asking whether people seem more or less fit than their ancestors in some general sense. Fitness in evolutionary terms does not mean athleticism, beauty, or strength. It means reproductive success in a specific environment. A body can seem physically unimpressive by heroic standards and still pass on its genes very effectively. A magnificent body can fail to do so. The word itself has been badly distorted in ordinary speech, and with that distortion comes much confusion. The modern world makes the confusion worse because it is crowded with technologies that compensate for bodily limits. The fact that a person survives with corrective lenses, insulin, hearing aids, dental implants, or emergency surgery does not prove evolution has stopped. It proves that selection pressures have changed. If some traits that once sharply reduced survival now matter less because medicine and social support intervene, then those particular pressures are relaxed. But relaxing a pressure is not the same as ending evolution altogether. It merely alters which inherited differences matter most. One filter weakens, another may strengthen, or several smaller filters may replace one brutal one. Scholars still debate the scale of this shift because the evidence remains incomplete, and because modern environments are not one single environment. They're a patchwork of privilege, deprivation, disease exposure, infrastructure, diet, education, toxins, stress, and mobility, all operating unevenly across the planet. To understand why evolution never truly stops, it helps to picture a population not as a set of finished individuals, but as a flowing river of inheritance. Every generation carries variation. No two people are genetically identical apart from identical twins, and even they diverge in important biological ways over time. Some differences are obvious, many are not. In one environment, a particular immune trait may offer a slight advantage. In another, it may do little. A metabolism that stores energy efficiently might help under scarcity and hinder under abundance. A trait linked to fertility might matter more than one linked to raw physical endurance. A pattern of mate choice within a society can amplify certain characteristics independent of survival. Move that population, alter its disease landscape, change its diet, delay the age of first childbirth, transform infant care, reduce maternal mortality, or expose it to new chemicals, and the river shifts course. None of this guarantees rapid or dramatic change. Evolution can be slow. In large populations, especially those with extensive mixing, strongly visible changes may take a very long time to become widespread, unless selection is powerful. Human generation times are long compared with those of many organisms. Cultural change can happen in years, while genetic change often unfolds across centuries or millennia. That mismatch creates an illusion. People watch cities rise, industries expand, medicines appear, family size collapse, and digital life transform daily behavior in just a few generations. Then conclude that genes must be irrelevant because bodies have not remodeled themselves on the same schedule. But bodies were never going to keep pace with the speed of modern institutions. The lag is built into the timescale. There is another reason people underestimate ongoing evolution. Many traits do not map neatly onto one gene or one outcome. Height, for example, is influenced by many genes and also by nutrition, disease burden, and childhood conditions. Immunity is vastly more complex, involving entire systems interacting with microbes that themselves evolve. Fertility, cognition, metabolism, and disease risk are similarly tangled. When a trait is shaped by many genes and powerful environmental effects, change becomes difficult to read from casual observation. A population may be undergoing measurable genetic shifts without producing the kind of clear anatomical spectacle that popular imagination expects. The evidence often has to be reconstructed through careful statistics, health data, genomic comparisons, and long-term demographic records. In other words, the modern form of the question is not well suited to the naked eye. The human tendency to tell stories in terms of endings also plays a role. There's something emotionally satisfying about declaring that evolution has handed the species over to culture, that biology has done its work and technology now governs the rest. It fits a certain modern self-image. Humans become the first organism to step outside the old rules, not because genes vanished, but because institutions, medicine, and engineering became strong enough to shelter the species from the traditional consequences of frailty. There is some truth there. Human beings have indeed altered their selective environment to an extraordinary degree, but the temptation is to turn alteration into exemption. That is where the claim becomes misleading. No species can exempt itself from inheritance. It can only change the terms under which inheritance matters. Even traits that appear neutral under one set of conditions can acquire new importance under another. A population living with chronic food instability experiences different pressures than one living with abundant processed calories. A population exposed to heavy infectious disease burdens faces different filters than one protected by sanitation and vaccines, though even there the story is never complete. A society in which childbirth is medically supported imposes different risks than one in which maternal mortality remains high. A world of delayed reproduction, assisted fertility, and widespread migration is different again. The body does not stop encountering pressures. It encounters a moving target. What changes is not the existence of evolution, but the architecture of the environment in which it occurs. This is why it is dangerous to use past selection as the standard for recognizing present selection. Ancient human life often makes evolutionary pressure appear obvious because the consequences are immediate and brutal. Modern life often obscures it because systems absorb many of the shocks that once acted directly on the body. Yet absorption is not elimination. If medicine allows more people with certain inherited conditions to survive and reproduce, that changes the population. If new diets alter which metabolic traits become costly or beneficial, that changes the population. If migration brings previously separated groups together, reshaping the distribution of genetic variation, that changes the population. If some people have children earlier, later, more often or less often for reasons partly linked to inherited tendencies interacting with social structure, that also changes the population. Evolution can continue even in a world dominated by choices, institutions, and technology, because those things become part of the environment to which genes respond. The language of stopping is especially misleading because it suggests a clean boundary. There is no moment in human history when the old evolutionary engine simply shuts down. There are transitions, asymmetries, and overlaps. Some pressures decline in one century and reappear in another. Disease burdens fall, then new pathogens emerge. A nutritional problem is solved, then replaced by another. A technology that protects one weakness creates a different kind of strain somewhere else. What survives in the record suggests continuity disguised as change. The human story is not nature first and culture later, as if one stage cleanly replaces the other. It is a long entanglement in which culture increasingly modifies nature's filters, but never fully escapes them. And that entanglement has consequences for the body even when the results are not immediately visible. Consider how often the modern human form is treated as though it were universal and final. Yet human populations today still differ in predictable ways shaped by ancestry, environment, and history. Some of those differences reflect very old adaptations, some are more recent, some remain under debate. The point is not to exaggerate them, still less to turn them into crude stories of superiority. It is to notice that the species is not biologically static, it never was. Even if the broad outline of the body remains recognizably human across millennia, the details continue to shift. There is no law stating that once a species builds cities and hospitals, inherited variation ceases to matter. If anything, the complexity of modern life may make some forms of selection harder to see, precisely because the old visible filters have been replaced by diffuse, interconnected ones. So before the argument can go any further, one misconception has to be left behind. Evolution is not a spectacle reserved for distant prehistory. It is not limited to moments when ice sheets advance, predators circle, and famine strips the landscape bare. It is an ongoing process of inherited change across generations, sometimes dramatic, sometimes subtle, sometimes driven by selection, sometimes shaped by chance, sometimes amplified by migration and mixture. It continues wherever reproduction, variation, and differential inheritance continue. The real question, then, is not whether evolution has stopped. It is which forces once acted most strongly on human bodies, which of those have weakened, which new ones have taken their place, and why the modern form of change can feel so eerily invisible compared with the raw clarity of the prehistoric world. That older world is where the human body is most legible. To see why the claim about stopped physical evolution gained so much force, it becomes necessary to return there, to the long ages when nature's filter is harsh enough to be read almost directly in scar tissue. Infant graves, seasonal hunger, and the fragile arithmetic of survival. In those settings, the body is not buffered by much at all. It meets the world head-on, and the world answers without mercy. For most of human existence, the body lives under conditions so severe that modern people can struggle to imagine them with any real clarity. It is easy to say that life was hard in prehistory. It is much harder to sit inside what that hardness actually means. A body opens its eyes in a shelter that leaks smoke and cold. The nearest source of water may also be the nearest source of parasites. Food is never guaranteed. There are seasons of relative plenty, but there is no stable abundance, no warehouse, no refrigeration, no quiet confidence that tomorrow's meal can be summoned by convenience. The land gives, then withholds. Game shifts its routes. Storms arrive wrong. Plants fail. A small injury becomes a large danger. A cut becomes an infection. A fever becomes a death. A difficult labour becomes 2 deaths. Children survive at rates that would shock the modern conscience. Mothers do not always live long enough to raise those who do. Old age exists, but it exists against odds and often with pain that cannot be repaired. Under such conditions, natural selection is not an abstract principle. It is written into the numbers of who reaches adulthood, who recovers from illness, who withstands winters, who bears children successfully, and whose children survive long enough to have children of their own. That does not mean prehistoric humans are simply weak creatures being endlessly crushed by nature. On the contrary, they are remarkably capable, flexible, observant, and resilient. They cross continents, enter deserts, survive near ice sheets, adapt to coastlines, forests, grasslands, mountains, river valleys, and monsoon rhythms. They learn plants, animal behavior, water sources, seasonal cues, migration paths, and the many small tricks by which life is preserved. But skill does not eliminate vulnerability. It only narrows the odds. The body remains exposed, and exposure is what makes selection so direct. Disease alone is enough to shape generations. Long before modern medicine, pathogens move through human groups with quiet force. Some are parasites living in water or soil. Some are infections spreading through wounds, food, breath, insects, or close contact. Small bands of foragers may avoid the worst crowd diseases that later afflict dense settlements, but they are not protected from illness itself. They face respiratory infections, intestinal disease, trauma-related infection, and the unpredictable devastation of childhood sickness. Once agriculture and permanent settlement begin, the disease burden changes and often worsens. But even in earlier settings, the body's engaged in a continual contest with microbes. A slightly more effective immune response can make a difference. A small inherited advantage in resisting a local disease may alter who survives to reproductive age. These changes are not visible in the heroic way people imagine evolution, yet they are among its most persistent engines. Then there is food, the most ordinary force in human history and one of the most unforgiving. Human bodies are expensive structures. Brains demand energy. Pregnancy demands energy. Lactation demands energy. Growth demands energy. Muscles, organs, immune responses, wound healing, and thermoregulation all demand energy. In a world of irregular access to calories, bodies live under constant negotiation with scarcity. Some years may be manageable, others are not. A failed migration of animals, a harsh winter, a drought, a local ecological shift, a flooded river crossing, a stretch of spoiled stores, a hunting injury to a skilled provider, any one of these can push a group toward crisis. The evidence remains incomplete, as it often must in prehistoric reconstruction. But what survives in the record suggests cycles of stress, adaptation, and loss repeated across long spans of time. Bodies better suited to endure shortage, better able to recover from lean periods, or better adapted to local food sources do not become immortal. They simply gain a margin. In prehistory, a margin is everything. Climate exerts its own relentless discipline. The human body is not naturally a creature of severe cold, extreme heat, thin air, or prolonged dryness without support. It becomes capable of surviving these through culture, movement, and partial biological adjustment. But the pressures are immense. Exposure kills, dehydration kills, heat exhaustion kills, hypothermia kills. A slightly different body shape may help with heat retention or heat loss. Skin pigmentation shifts across vast periods in relation to ultraviolet radiation, vitamin production, and environmental conditions. High-altitude populations show physiological adaptations that speak directly to oxygen scarcity. These are reminders that the body does respond to environment when the pressure is steady and intense enough. Yet for much of human time, climate is not a background, it is a selector. The Ice Age world is not simply cold in a poetic sense. It is metabolically demanding, logistically difficult, and brutally indifferent to miscalculation. Predation, often romanticized or ignored, plays a more limited but still real role. Early humans do not move through landscapes as uncontested masters. Large cats, hyenas, crocodiles, snakes, raptors, and other predators can and do kill people, especially the young, the injured, or the isolated. More often, perhaps, predation acts indirectly by shaping behavior vigilance, group cohesion, the timing of movement, the choice of shelter, the use of fire, the fear of darkness, the value of social alertness. The body under threat is not merely a stronger body, it is a coordinated body, a body attached to a nervous system tuned to risk, and to a group whose collective awareness matters as much as any one person's speed. Selection in this context does not reward simple brute force. It rewards suitability to the whole ecology of danger. And there is injury, one of the great hidden sculptors of the prehistoric human condition. Modern life contains accidents, but it also contains ambulances, antiseptics, orthopedic surgery, blood transfusions, pain control, and months of supported recovery. Prehistoric bodies do not have that luxury. A fall, a crush injury, a fractured limb, a torn ligament, a deep cut, a burn, or repeated strain from labor can permanently alter a life. Some individuals clearly survive severe injuries in the past, and this alone tells an important story. Human groups care for one another. They feed the injured, they protect the disabled, they carry those who cannot walk. That caregiving is one of the species' great strengths, and it complicates any simplistic picture of ruthless natural selection. Humans soften selection for each other even in deep prehistory. But the softening has limits. An injury that can be endured in one season may become fatal in another. A damaged body faces hunger, infection, immobility, and dependence under conditions where everyone is already operating close to the edge. Perhaps nowhere is the ancient filter more severe than in childbirth. The human pelvis is shaped by upright walking. The human infant has a large brain and a large head. The compromise between these two facts is never elegant. Birth in humans is unusually difficult among primates, and throughout history it has been dangerous in ways that modern medicine can obscure. Before surgical intervention, antibiotics, blood management, and trained obstetric care, childbirth is one of the most consistent threats to female survival. Infants die in labor, mothers die from obstruction, hemorrhage, infection, exhaustion, or complications that no skill available to the group can resolve. The consequences are profound. Any inherited trait affecting pelvic dimensions, fetal development, labor timing, or maternal health may influence survival and future reproduction. Yet here too the story's not simple. Human cooperation, midwifery, support, shared care becomes part of the adaptive system. Biology and culture are already intertwined, but the body still bears the risk directly. Infant and childhood mortality deepen the filter further. In many ancient settings, a shocking number of children do not survive to adulthood. Some die from infection, some from malnutrition, some from environmental exposure, some from congenital conditions. some from accidents, some for reasons that leave no trace in the bones. This is one of the hardest realities to hold in view because it transforms the scale of selection. When many offspring die before reproducing, any inherited difference that slightly improves early survival can have outsized consequences across generations. The species does not evolve because nature chooses the best in some grand moral sense. It evolves because countless small vulnerabilities are unevenly distributed, and environments are ruthless in how they exploit them. Yet if the prehistoric world is a filter, it is not a simple one. It does not always reward what modern imagination labels strength. A massively muscular body is expensive to feed. A reckless body dies. A body adapted to one niche may fail in another. Social intelligence, emotional regulation, memory, endurance, manual skill, and the ability to cooperate may matter as much as raw power. A person who can read a landscape, track an animal, identify edible plants, maintain fire, soothe conflict, care for children, notice weather shifts, and remember roots may contribute more to long-term survival than someone merely capable of impressive force. The body selected by prehistory is not a body built for spectacle. It is a body embedded in social life. This is one reason human evolution cannot be reduced to bones and muscles alone. Selection acts through entire ways of living. Still, the overall pattern remains stark. The ancient world kills with frequency and indifference. It kills before reproduction, during reproduction, and after reproduction. It kills through scarcity, infection, accident, weather, violence, and developmental fragility. It kills often enough that even modest inherited advantages can matter. This is what people usually mean, even if they do not phrase it carefully, when they talk about the brutal filter of prehistory. It is the age in which the body is exposed to direct consequences with very little buffering. If a trait helps under those conditions, it may spread. If it hinders, it may shrink in frequency or disappear. Not always. Chance still matters. Social support still matters. Drift still matters. The evidence is never complete enough to reduce the whole story to one mechanism, but no single explanation fully accounts for human physical history without giving this ancient harshness a central place. And because the filter is so visible, it becomes the model people carry into the present. They imagine evolution as something that requires open danger, high mortality, and the constant removal of the vulnerable. Once those features diminish, they assume the process itself must be over. But that conclusion depends on mistaking one especially dramatic form of selection for the whole phenomenon. Prehistory makes the logic easy to see because the connection between body and fate is often immediate. The modern world obscures that connection, it does not erase it. There is another complication, though, one that begins long before hospitals and antibiotics. Humans are not only animals exposed to selection, they're also animals that slowly learn to interfere with it, not abolish it, not escape it, but interfere with it in ways that transform the meaning of bodily adaptation. A body freezing in open wind begins to change its odds when it wraps itself in hides. A body that cannot digest raw tubers or tough meat as efficiently changes its future when food is cooked. A body exposed to darkness extends its day with fire. A body vulnerable to rain and predators builds shelter. These are not minor details added to the ancient story. They are the beginning of a revolution in which humans alter the environment rather than waiting for the environment alone to alter them. That shift will not end the brutal filter, but it will start to soften it. The body still matters, but it begins to matter differently. Evolution remains real, yet culture enters the process as a force powerful enough to change which traits are favored, which weaknesses are tolerated, and which dangers are reduced before they can do their work. The old raw contest between flesh and world does not disappear. It becomes mediated. And once that mediation begins, the long path toward the modern confusion toward the idea that humans may have stopped evolving physically has already begun. The first great softening of the ancient human ordeal does not arrive with cities, hospitals, or machines. It arrives in sparks. It arrives in embers carried from place to place, in the memory of dry tinder, in the guarded centre of a camp where flame becomes more than heat. Fire changes everything so early and so completely that it can vanish into the background of the human story. Mistaken for a simple tool rather than the beginning of a new kind of relationship between body and environment, a body that once had to endure cold directly can now extend warmth into the night. A body whose teeth and gut once laboured over raw fibres, tough meat, and risky food can now draw calories from cooked meals that are softer, safer, and easier to digest. A body vulnerable to darkness can now carve out a circle of light in which predators hesitate, insects thin, and social life continues after sunset. Fire does not remove danger, but it changes the terms. It creates distance between flesh and world. That distance matters because it marks one of the earliest moments when humans begin adapting by external means, rather than waiting for anatomy alone to solve the problem. Fur does not need to grow thicker if hides can be wrapped around the skin. Claws are unnecessary if cutting edges can be shaped from stone. Human teeth do not need to become the jaws of a lion if fire and tools can process food before it reaches the mouth. This is not an escape from evolution. It is a new input into evolution, because every successful technology alters which bodies are exposed to which pressures. The evidence remains incomplete on the exact timing and sequence of many early developments, as it often must across such deep stretches of prehistory. But what survives in the record suggests a slow accumulation of innovations that steadily change the adaptive landscape. Clothing is one of the clearest examples. Naked human skin is an unlikely companion for many of the climates the species eventually enters. Hair alone cannot account for successful life across freezing winds, high latitudes, and winter ground that strips heat from the body by contact. At some point, people begin using animal skins, plant fibers, and later more refined materials to construct an artificial envelope around themselves. That envelope matters in immediate practical ways. It preserves heat, reduces exposure, protects from abrasion, insects, and sunlight, and extends the range of landscapes in which a human body can survive. But it also matters in evolutionary terms because it reduces the pressure for certain purely anatomical solutions. A population equipped with clothing may move into cold regions faster than bare biology could have managed alone. Culture expands the territory before genes catch up, and perhaps prevents some pressures from ever becoming dominant in the old direct way. Shelter does something similar. A cave, a windbreak, a hut, a roof of hide, a wall of branches or packed earth. Each is a way of modifying climate rather than merely enduring it. The human body still wakes in the same skin, with the same need for warmth, dryness, sleep, and recovery. But the immediate violence of rain, frost, wind, and heat is partly reduced by built space. Even the simplest shelter can turn an exposed night into a survivable one. Once again, the important point is not that bodies become irrelevant. A badly nourished, injured, or ill body can still perish inside a shelter. A freezing climate still demands labour, fuel, movement, and knowledge. But the environment is no longer acting on flesh alone. It is acting on flesh plus invention. That combination becomes the true human niche. Cooking may be even more transformative than warmth. Raw food imposes costs. It takes time to chew, energy to digest, and in many cases carries risks from pathogens and toxins. Cooked food changes the arithmetic. Calories become more accessible. Some harmful organisms are killed. Texture softens. Nutrients become easier to extract. Over immense periods, these changes have consequences not only for daily survival, but for the body itself. Some scholars have argued that cooking helps support the energy demands of larger brains by making food more efficiently usable. The details of such debates remain active, and no single explanation fully accounts for every shift in human anatomy and life history. But the larger principle is clear enough. Once food is transformed before it enters the body is living within an invented metabolic environment. Human beings are no longer eating only what nature presents in raw form. They are pre-processing the world. Tools, too, alter the body's relationship to selection in quiet but profound ways. A sharp stone extends the hand, a spear extends reach, a needle extends care into clothing and repair. Containers extend storage, nets and hooks extend access to fish and small prey. Grinding stones alter what plants can be eaten. Each tool broadens the range of survival strategies available to a body that by itself is physically unimpressive in several obvious ways. Human teeth are not ideal weapons. Human speed is modest. Human claws are non-existent. Human skin is fragile. Human infants are helpless for unusually long periods. Yet these apparent disadvantages are steadily offset by an expanding technical world. The body becomes less a standalone unit and more the biological core of a cultural system. In evolutionary terms, that means selective pressures begin to distribute themselves differently. Success depends not only on bodily traits but on participation in knowledge, cooperation, memory, and craft. This is where the idea of physical evolution becoming less obvious starts to take shape long before modernity. A species that survives through external aids will not always need dramatic anatomical transformation to solve every problem. If winter can be managed with fire, clothing, and shelter, then there may be less selection for cold-specific bodily changes than there would be in a species forced to face the cold naked. If dangerous food can be cut, pounded, cooked, fermented, or stored, then jaws, teeth, and guts do not carry the entire burden alone. If social groups share food and protect the vulnerable, then injury or temporary weakness does not always mean reproductive failure. Culture does not cancel biology, it redistributes risk. And when risk is redistributed, the body may change more slowly, or in different directions, than it would under raw exposure. The social dimension of these technologies is just as important as the objects themselves. Fire is rarely a solitary achievement in human history. It is maintained, taught, guarded, and shared. Shelter is built cooperatively. Clothing requires knowledge passed between generations. Tool traditions spread through imitation and teaching. This means that survival becomes tied ever more tightly to belonging. A body isolated from knowledge is a body at greater risk. Memory, communication, patience, and group cohesion become part of the adaptive package. Physical selection is now entangled with social selection. The strongest individual is not necessarily the most successful if that strength is paired with recklessness, conflict, or poor integration into the group. A person who remembers roots, seasons, animal behavior, medicinal plants, fuel sources, and crafting methods may contribute more to long-term survival than someone merely capable of lifting more weight. The human body is being shaped in an environment where tools and social systems increasingly matter as much as bone and muscle. There is a temptation to imagine this process as a straightforward march toward comfort. It is nothing of the kind. Fire burns as well as warms. Smoke damages lungs and eyes. Shelters collapse or trap disease. Stored food can rot. Close quarters attract parasites. Clothing can fail in wet cold and become its own danger. Tools create new forms of injury and conflict. Every solution opens a new field of problems. Scholars still debate the exact balance of cost and benefit for many ancient innovations, because the archaeological record is fragmentary, and because technologies do not enter all places in the same way or at the same speed. But even with those uncertainties, the broader pattern is unmistakable. Humans increasingly survive by reorganizing the environment around the body, not simply by waiting for the body to change first. That reorganization has another consequence. It allows humans to move into environments that would otherwise remain marginal or lethal. Fire, clothing, shelter, and food processing do not just improve survival where people already live, they enable expansion. Groups push into colder latitudes, harsher seasonal regimes, and more variable landscapes. They survive not because their bodies have fully adapted in advance, but because culture creates a temporary bridge. Over time, biological adaptation may follow in some respects, or it may not. The key point is that the sequence has changed. Environment no longer acts first and anatomy responds later in clean isolation. Instead, culture intervenes immediately, blunting some pressures, amplifying others, and permitting human occupation of places for which the body alone would be poorly suited. This is one reason human evolution becomes harder to read in simple physical terms. The body is no longer confronting a fixed natural challenge. It is confronting a challenge already modified by human behavior. Even rest itself begins to change. A sheltered sleeping place, a controlled fire, and some degree of communal watchfulness alter the quality of recovery. Recovery matters enormously in harsh environments. Wounds heal or fail to heal during rest. Immune systems work under the burden of energy availability, cold, stress, and sleep disruption. A body protected even slightly from the elements may reproduce more successfully, raise children more effectively, and survive temporary illness more often than one left in direct exposure. Such advantages may seem mundane compared with the grand drama of hunting large animals or surviving glacial climates. But evolution often turns on the mundane. A few more survivors here, a few healthier infants there, a few mothers recovering rather than dying after prolonged hardship over generations. Small changes in buffering can alter the entire structure of selection. This is also the point at which the human species begins to exhibit its most unusual evolutionary trait, the ability to let culture absorb pressure faster than genes can. Other animals alter their surroundings. Of course, many build nests, burrows, hives, or dams. But humans turn environmental modification into a cumulative inheritance system. Fire techniques improve, sowing improves, shelter design improves, food storage improves, knowledge travels, mutates, and accumulates. A child does not inherit only genes. A child inherits methods. Those methods change the significance of the genes. This creates a feedback loop between biology and culture that becomes stronger with every generation. It does not eliminate physical evolution, but it makes physical evolution only one part of the story. The body is still under selection, yet the environment doing the selecting is increasingly one that humans have partly made themselves. And that is perhaps the most important point. By softening cold, darkness, hunger, and exposure, early technologies do not merely make life easier, They begin dissolving the old clarity with which the world once acted on the body. The prehistoric filter remains brutal, but it is no longer raw in the same way. The body now survives partly because of learned behaviors and external structures. A person with a marginally weaker tolerance for cold may live because clothing and fire close the gap. A child with temporary vulnerability may survive because shelter and cooked food carry them through. A group can endure a difficult season because storage and cooperation redistribute scarcity. Each of these interventions is small compared with the vast protective systems of the modern age. But together they mark the beginning of a profound shift. Human beings are no longer just evolving within environments, they are engineering them. Once that process begins, it becomes impossible to tell the story of human bodies as though nature alone remains in command. The old selective pressures have not vanished, but they are being edited. Some are softened, some are delayed, some are transformed into social and technological problems rather than direct biological trials. This is the long prehistory of the modern claim that humans may have stopped evolving physically. The claim sounds contemporary, but its roots go back much farther. It begins the moment a species learns that a firelit shelter can do work that flesh once had to do for itself. Yet the softening does not stay small. Over time it grows into something far more disruptive. The next great turning point is not merely a better campfire or a warmer cloak, but an entirely new way of living settled, cultivated, crowded, domesticated, and biologically transformative. If early technology starts to buffer the body from the world, agriculture will do something even more consequential. It will create new worlds altogether, and in doing so, it will reshape the human body in ways that prove culture can generate fresh selective pressures every bit as powerful as the ancient natural ones it partly replaced. The agricultural revolution is often described as a triumph because it leads, eventually, to cities, states, writing, stored wealth, specialization, monumental architecture, organized religion, taxation, bureaucracy, empire, and all the recognizable machinery of later civilization. But for the human body, the first stages of that revolution are not a clean ascent into better living. They are a biological upheaval. Farming changes where people live, what they eat, how they work, what diseases they face, how often women bear children, how children grow, and what kinds of inherited traits begin to matter most. If early technologies like fire and clothing soften certain ancient pressures, agriculture does something more radical. It replaces one selective environment with another. For foragers, diet is often varied, though never guaranteed. It depends on place, season, skill, and ecological richness, but it can include wild plants, tubers, nuts, fruit, shellfish, fish, insects, birds, and game in combinations that shift across the year. Farming narrows that flexibility. Once a population depends heavily on a few domesticated crops, the human body begins living on a more concentrated nutritional base. That concentration has advantages. It can support larger populations. It can create stores. It can stabilize some food access from year to year, at least in favorable conditions. Yet it also introduces new vulnerabilities. Crop failure becomes catastrophic in a way that a broad-spectrum foraging system may sometimes avoid. Dependence on cereals can reduce dietary diversity. Deficiencies emerge. Teeth begin to tell the story in cavities, enamel defects, wear patterns, and signs of stress. Bones tell it too, in stature changes, workload patterns, developmental disruptions, and disease burdens that appear to intensify rather than disappear. This is one of the most surprising lessons in the long human story. The invention that eventually supports civilization does not necessarily make the average body healthier at first. In many early farming societies, people become shorter than some of their foraging predecessors. Their skeletons can show heavier repetitive labor, nutritional stress, and signs of infectious disease associated with denser settlement. The evidence is not identical everywhere, and scholars still debate the degree to which these patterns vary by region, crop type, climate, and chronology. But the overall picture remains striking. Farming increases the amount of food that can be produced from a given landscape. But it also ties human survival to grinding daily labor, seasonal risk, narrower diets, and close coexistence with waste, vermin, and domesticated animals. The body enters a new bargain. More people can live. Individual bodies may pay the cost. That cost begins with labor. Agriculture is not simply the scattering of seeds into generous earth. It is digging, planting, weeding, hauling, harvesting, grinding, storing, repairing, carrying water, processing grain, tending animals, clearing land, and enduring the repetitive strain of tasks that return every season. The body now moves differently through time. Foragers often work hard, sometimes brutally hard, but early farmers are tied to routines of repeated physical demands that shape joints, muscles, spines, and limbs in distinctive ways. Knees, backs, shoulders, wrists, and hips absorb the consequences. Repetition becomes destiny. This is one reason farming societies can leave behind skeletons marked by workload stress in ways that feel almost modern in their grim familiarity. Civilization begins not with effortless abundance, but with bodies bent toward the field. The demographic consequences are equally important. Sedentary life changes reproduction. Women in settled agricultural communities can often bear children more frequently than highly mobile foragers, partly because permanent settlement reduces the burden of moving infants and possessions over long distances. Stored food and weaning practices alter the spacing of births. Population growth accelerates. More births mean more chances for lineage survival, but they also mean greater physiological strain on mothers and greater demands on household food systems. Children crowd into settlements where disease spreads more easily. Mortality can remain high, even while total population rises. This is one of the recurring paradoxes of the agricultural world. More people survive in aggregate, yet many individuals live under harsher and less healthy daily conditions than those who came before. Then there are animals. Domestication changes human history not only through meat, milk, traction, wool, and transport, but through pathogens. Once humans live near herds and flocks, share enclosed spaces, handle dung, store grain that attracts pests, and concentrate population in permanent settlements. The microbial landscape transforms. Infections that once struggled to sustain themselves in small mobile bands gain new opportunities in dense communities. Some diseases make the jump from animals to humans. Others thrive in the unsanitary byproducts of settled life. The village and the early town become biological experiments in crowding. From that crowding comes one of the great engines of later human evolution: epidemics and endemic disease burdens shaped by population density, immunity, and repeated exposure. Farming does not spare the human body from selection, it subjects it to new kinds. Diet under agriculture creates some of the clearest examples of culture-generating biological change. Consider lactase persistence. The ability of some adults to digest lactose in milk. In most mammals, and in many human populations historically, the enzyme needed to digest lactose declines after childhood. Yet in certain populations with long traditions of dairying, genetic changes that maintain lactose digestion into adulthood become far more common. This is not a trivial footnote. It is a vivid demonstration that cultural practices can create strong selective pressures. The keeping of cattle, sheep, goats, or other milk-producing animals changes the food environment. In that environment, bodies able to use milk efficiently may gain a nutritional advantage, especially in times of scarcity or where dairy becomes a major calorie source. Culture opens the door. Biology follows. The claim that humans stopped evolving physically becomes much harder to sustain when such examples are brought into view. A similar logic applies to starch digestion and other metabolic traits. Populations with long histories of grain-based diets may experience selection related to how carbohydrates are processed. Though the details are complex and not reducible to single simple stories. The evidence remains incomplete in many cases, and researchers are cautious for good reason, but the broader principle stands firm. Agriculture changes food, changed food changes bodies. Not instantly, not uniformly, and never in a way that erases environmental and social variation, but across generations the biological consequences accumulate. Teeth, guts, immune systems, growth patterns, and metabolic pathways all begin interacting with the settled food economy in ways that foraging life did not require. Even the human face may carry traces of these shifts. Softer diets and processed foods can alter chewing demands, jaw development, and dental crowding over long spans. Though scholars debate how much of modern variation reflects ancient evolutionary change versus developmental responses to diet and behavior, what matters here is not one definitive answer to every anatomical detail. It is the growing recognition that agriculture transforms the whole developmental setting in which bodies grow. A child raised on a different diet, exposed to different pathogens, living at different population density, and subject to different labor expectations does not simply become the same human in a different costume. The body is built under new instructions, some genetic, some environmental, some inseparably mixed. Social hierarchy deepens the pattern. Surplus permits inequality, and inequality has biological consequences. Once some people control more land, grain, livestock, and labor than others, access to food and safety is no longer distributed evenly, even within the same settlement. One body grows with better nourishment, another with chronic deficit. One survives repeated illness because resources are available, another does not. One woman bears children under protected conditions, another under relentless labor stress. One child reaches adulthood with stronger bones and greater height, another carries lifelong marks of deprivation. This matters because selection never acts on a population in the abstract. It acts through real distributions of stress, privilege, disease, and opportunity. Agriculture does not create a uniform human environment. It creates stratified ones, and those strata shape who lives, reproduces, and passes on inherited traits. There is also the problem of dependence. Foragers can move when local resources collapse. Farmers are tied to land, seasons, and stored harvests. Their worlds can be productive, but also fragile. Drought, flood, pests, salinization, conflict, or soil exhaustion can become collective disasters. A failed crop does not merely mean hunger for a few days. It can mean famine, migration, violence, demographic collapse, and cascading disease. The settled body is buffered from some ancient uncertainties, but it becomes hostage to others. A population dense enough to support impressive cultural complexity may be dense enough to suffer spectacularly when that complexity falters. This too becomes part of the evolutionary setting. Bodies are now living inside systems, and systems can fail. The great irony is that agriculture proves the very thing that modern claims about halted physical evolution tend to overlook. Human beings do not need untouched wilderness or raw prehistoric struggle in order to keep evolving. They only need inherited variation interacting with real differences in survival and reproduction under changing conditions. Farming provides those conditions in abundance. It changes the timing of births, the structure of households, the burden of disease, the contents of the diet, the scale of inequality, the demands of labor, and the geography of risk. It does not slow history down to let bodies catch up. It forces bodies into a newly invented world and lets inheritance sort out the consequences over generations. This is why the agricultural revolution is such an important turning point in the larger argument. It breaks the easy opposition between natural and cultural selection. The old story says nature shaped prehistoric humans and culture later took over. But farming makes the two impossible to separate. Human choices produce fields, villages, granaries, corrals, and seasonal routines. Those choices then create real biological pressures. Disease becomes denser because settlement becomes denser. Diet becomes narrower because agriculture becomes narrower. New foods become valuable because domestication makes them available. Fertility patterns change because mobility declines. The environment is no longer simply out there. It is built, and then it acts back on the body with all the force of nature itself. In that sense, agriculture does not free humans from evolution. It drags them into a new phase of it. The body that survives in a village is not necessarily the body best suited to a mobile foraging world. Traits that once mattered less can become central. Traits once useful can become burdens. The ancient filter has not disappeared. It has been rewritten in the language of crops, crowding, livestock, labor, and hierarchy. This is one of the strongest reasons to be wary whenever someone claims that modern humans stopped evolving physically. Long before the modern age, human culture was already generating selective environments powerful enough to leave marks in genes, skeletons, and demographic patterns. And agriculture is only the beginning of that transformation. Once people gather in larger permanent settlements, build walls, dig drains, store grain, accumulate waste, exchange goods, organize power, and crowd into towns, the body enters an even stranger landscape. The village becomes the city, and the city invents new survival rules, rules in which human success depends less on individual toughness in open nature and more on endurance inside dense, unequal, disease-prone systems of collective life. Once human beings begin living in permanent settlements at meaningful scale, the body enters a world unlike any it has known before. A camp can be abandoned. A foraging range can shift. A bad season may force movement. But a village, a town, a city, these are accumulations. They hold grain, tools, walls, dung, smoke, insects, animals, waste, authority, memory, and debt all in one place. They create stability of a kind, but also concentration, and concentration changes everything. The air changes. The water changes. The rhythm of disease changes. The meaning of danger changes. In older landscapes, a person may die because nature is too open. In settled life, a person may die because other people are too close. Crowding is the first great alteration. Many infectious diseases thrive only when human groups become large and dense enough to sustain chains of transmission. A scattered band cannot support the same microbial ecology as a town packed with bodies, refuse, stored food, and domesticated animals. Once people settle, pathogens find continuity. They find children close together. They find contaminated water. They find dirty hands, shared vessels, poor drainage, and insects breeding in stagnant places. The city becomes a biological engine. Epidemics are no longer rare intrusions alone. In some societies, disease becomes part of the background pulse of ordinary life. Fevers come and go. Childhood illnesses sweep through neighborhoods. Parasites persist. Respiratory infections spread in enclosed spaces. The body is still under selection, but the selector is no longer simply winter, hunger, or injury in open country. It is the crowded architecture of civilization itself. This changes which traits matter. In a sparse prehistoric setting, raw endurance and local ecological skill may dominate survival. In settled life, resistance to pathogens can become increasingly important. So can childhood resilience under chronic disease burden. So can the ability to withstand contaminated food and water, though no body tolerates those burdens without cost. Scholars still debate the precise evolutionary consequences of specific urban disease environments across different regions and eras, because the evidence remains incomplete, and urbanization is never a single universal process. Some cities are relatively small, some are seasonal, some maintain better water systems than others, some are surrounded by marshes or trade routes that alter their disease profile. Yet the broader truth is clear enough. Settlement changes the microbial battlefield, and once the battlefield changes, inheritance matters differently. Cities also transform survival by making it collective. In the open landscape, an individual body may succeed or fail against weather, terrain, prey, and predators with relatively direct consequences. In urban life, the individual depends on systems. Clean water depends on infrastructure or its absence. Food depends on supply chains, storage, distribution, labor, taxation, and political stability. Safety depends on walls, guards, law, custom, family ties, and the willingness of others to intervene. A person may be physically robust and still die because a drainage system fails. Grain prices rise, a ruler mismanages stores, or a contagious disease enters through trade. This does not mean bodies become irrelevant. It means physical survival is increasingly mediated through institutions. The body is judged by the city's systems as much as by the weather outside its gates. Social hierarchy sharpens these forces further. Ancient and pre-modern settlements are rarely egalitarian spaces. Wealth accumulates unevenly. Power gathers in households, lineages, temples, palaces, estates, garrisons, and bureaucracies. The result is that one city contains many biological worlds. Some people sleep in dry, protected houses, eat relatively varied diets, and can withdraw from danger when illness spreads. Others live in cramped quarters, work exhausting hours, consume poorer food, and remain exposed to filth, smoke, and violence with little escape. The same epidemic moves differently through these strata. The same famine lands differently. The same pregnancy carries different odds depending on labor demands, status, and available care. Selection, if it is happening, is therefore never uniform. It is filtered through class, occupation, caste, slavery, patronage, kinship, and access. No single explanation fully accounts for how all of these pressures combine, but what survives in the record suggests that inequality itself becomes part of the evolutionary environment. Work changes too. The city does not abolish labor, it specializes it. Some people haul stone, some pound metal, some grind grain daily for years, Some carry water, manure, timber, or bricks. Some row, march, mine, forge, weave, dig, and climb under conditions that mark the skeleton and wear the body down in patterned ways. Others sit, administer, calculate, write, store, and command. The human frame is still being shaped by activity, but the kinds of activity are now linked to social role more than broad ecological necessity. A body may suffer not because it cannot survive in nature, but because it is trapped in a labour niche from childhood onward. Repetitive stress, injury, nutritional deficit, and occupational hazard become ordinary facts of settled life. Civilization often looks grandest from a distance. Up close, it is full of bodies being used up. At the same time, cities reward traits that are not easily captured by the old image of physical evolution. Tolerance for crowding, impulse control under social pressure, memory for rules and obligations, skill in negotiation, the ability to manage delayed rewards, sensitivity to status, and navigation of hierarchy all matter in dense societies. It would be simplistic to claim that urban life directly selects for one personality template, and scholars remain cautious on such questions for good reason. Human behaviour is shaped profoundly by culture, institutions, upbringing, and chance, not just genes. But it is clear that once large settlements emerge, survival and reproduction are no longer tied mainly to bodily toughness in the old wild sense. They are tied to functioning inside systems of law, kinship, labour, authority, and exchange. The body survives because the social organism permits it to. That social organism can also fail with extraordinary speed. Cities depend on stored grain, transport, order, and specialised labour. If one part of that chain breaks, the consequences spread widely. A drought upstream becomes hunger in crowded neighbourhoods. A war interrupts trade and empties markets. A siege traps bodies behind walls and turns density into a weapon against the inhabitants. A contaminated water source becomes a citywide crisis. One of the paradoxes of urban life is that it allows larger populations and more complex culture, while also creating forms of collective vulnerability that earlier bands and villages would never experience at such scale. This too shapes which lives continue and which do not. The strongest body in the city is still exposed to failures far beyond its control. Even sanitation, when it appears, reveals the deeper logic of settled evolution. Drains, sewers, bath systems, waste management, and water engineering are among the greatest achievements of urban civilization, but they are also signs of how unnatural the city is for an unmodified human body. Dense populations produce biological risk that must be managed artificially. Where management succeeds, mortality falls. Where it fails, disease returns. In that sense, the city anticipates the modern world. It shows that human survival increasingly depends on technologies and institutions that buffer the body from environments humans themselves have created. A well-maintained aqueduct or sewer does for ancient urban life what later antibiotics, vaccines, and modern sanitation will do on a vastly larger scale. It does not stop evolution. It changes the pressures by redistributing danger away from some bodies and toward others, or by reducing the force of one filter so that another becomes more visible. This is why it is misleading to imagine cities as places where natural selection simply fades. In some ways, urban life may relax certain old pressures. Large predators matter less behind walls. Exposure to open cold may be reduced by denser construction. Food can be stored and redistributed, at least when systems hold. But new pressures rush in to fill the space. Infectious disease intensifies. Pollution accumulates. Water quality becomes critical. Social competition shapes access to mates and resources. Violence becomes organised rather than sporadic. Infant survival depends on maternal status, wet nursing, sanitation, and crowd disease. The city is not a release from selection, it is a redesign of selection. There is another subtle shift here as well. In older environments, survival often depends on the direct relationship between one body and the landscape. In settled life, survival increasingly depends on networks. A child lives because someone else grows grain, someone else stores it, someone else keeps roads open, someone else repairs wells, someone else helps in childbirth, someone else transmits knowledge about treatment, ritual, or hygiene. That network allows more bodies to survive than a purely individual struggle would permit. It protects weakness in ways prehistory sometimes could not. Yet it also means that inherited physical robustness is no longer the only, or even primary determinant of life chances in many contexts. This is one reason people later begin to suspect that physical evolution must be slowing. The body is less visibly tested on its own. Its fate is tied to collective maintenance. Still, collective life never fully escapes the arithmetic of reproduction. Not everyone has equal opportunity to form unions, raise children, or secure lineage continuity. In stratified urban societies, elites may have more surviving offspring, or sometimes fewer depending on historical circumstance, inheritance patterns, and mortality regimes. Labouring classes may reproduce early and often under heavy losses. Disease may strike children before adulthood. Migration may replenish cities demographically when urban death rates exceed birth rates, as has happened in some historical periods. All of this matters because evolution concerns the transmission of inherited variation, not merely who looks healthiest at any given moment. Urban populations are not static reservoirs. They are churned by death, fertility, movement, and class structure. The body remains in the story, but hidden within social machinery. What makes cities so important in this larger argument is that they force a new definition of what counts as physical challenge. The challenge is no longer only whether a human can run, hunt, endure cold, or survive a wound in isolation. It is whether the human organism can persist inside a dense artificial habitat full of microbes, hierarchy, labour specialisation, inequality, and institutional dependence. This is still a bodily question, but it is a bodily question transformed by culture. Civilization does not end evolution. It folds evolution into systems that are harder to see and harder to interpret. The human body becomes a participant in environments made of grain taxes, drainage ditches, alleyways, livestock pens, tenements, workshops, and trade routes. By now the old prehistoric filter is already fading from view, not because it has vanished everywhere, but because many humans increasingly live under survival rules created by their own societies. Strength still matters, endurance still matters, health still matters, but increasingly, those traits operate inside collective structures that reward, punish, protect, or expose in complicated ways. This is the long prelude to the modern confusion. If survival depends on the city, and the city can keep alive bodies that open wilderness might not, then it begins to look as though physical selection itself has weakened. That impression is not entirely wrong. Some older pressures do soften, but the city also proves something else when culture changes the environment. It does not suspend biology. It simply writes biology into a new set of rules. And eventually those rules are altered again by something even more powerful than the city alone. The next great shift is not merely crowding, hierarchy, or infrastructure, but deliberate intervention in the old patterns of death themselves. Once medicine, obstetrics, public health, and germ control begin preserving lives that earlier centuries would have lost in enormous numbers. The ancient filter is not just blurred, it is interrupted on a scale human history has never seen before. For most of history, medicine offers comfort more often than rescue. There are healers, herbalists, bone setters, surgeons of varying skill, midwives, ritual specialists, and long traditions of observation, trial, and inherited treatment. Some remedies help, some do nothing, some cause harm. People are not ignorant of the body in any absolute sense. They know wounds, fever, swelling, pain, birth, digestion, and death with a practical intimacy modern people rarely possess. But there is a hard boundary to what pre-modern medicine can accomplish. A deep infection still spreads. A difficult labour still becomes a crisis. A broken limb may heal crooked or not at all. A child with dehydration from diarrhea can die in a matter of days. A wound that looks survivable turns fatal because bacteria, invisible and unrecognized, are already at work. The body remains exposed to old consequences even when others try to help it. Then, over a relatively brief span in historical terms, something extraordinary happens, not all at once, not evenly, not everywhere, and never with perfect success, but enough to alter the basic arithmetic of human life. Surgery becomes safer. Anesthesia separates pain from procedure. Antiseptic practice begins reducing infection introduced by the healer's own hands and tools. Germ theory transforms the understanding of disease from vague imbalance or corrupted air into specific biological invasion. Clean water systems expand. Vaccination interrupts some of the deadliest infections. Antibiotics arrive later and change the treatment of bacterial disease with a force that would once have seemed miraculous. Blood loss can be managed more effectively. Childbirth becomes increasingly monitored, assisted, and, in emergencies, surgically salvageable. Public health measures reduce exposure before illness takes hold. The old pattern of bodily failure is not abolished, but it is broken open. This is one of the strongest reasons people say humans have stopped evolving physically. Modern medicine preserves lives that earlier worlds would have lost in overwhelming numbers. A premature infant survives. A woman with obstructed labour survives. A child prone to deadly infection survives. A person with severe nearsightedness survives and functions fully. A body with congenital heart problems, diabetes, kidney disease, immune dysfunction, or trauma that once meant early death can sometimes live for decades. In a prehistoric or even early modern setting, many such lives would never have reached reproductive age. In the medical age, they can. That is not a small change at the margins. It is a profound alteration of selection pressure, especially on traits linked to infant mortality, infectious disease, injury, and childbirth. Childbirth may be the clearest example because it sits so close to the center of reproductive success itself. For most of human history, maternal mortality is a constant shadow. Even in healthier and more resource-rich settings, labor can go wrong suddenly and irreversibly. A baby is badly positioned, labor is prolonged, hemorrhage begins, infection follows. The pelvis and fetal head do not match well enough for safe passage. Before modern obstetrics, these are often final events. The consequences ripple outward through infants left motherless, households destabilized, and lineages ended. Once obstetric care becomes more reliable, once antiseptic techniques, surgical delivery, blood management, prenatal monitoring, and trained attendants begin preventing death in large numbers, the ancient filtering effect of childbirth is dramatically reduced. Bodies that earlier centuries might not have carried through reproduction are now sustained by knowledge and technology. Few changes could matter more to the evolutionary story. Infant and childhood survival shift just as dramatically. Vaccines reduce deaths from diseases that once tore through families with terrifying routine. Rehydration, antibiotics, improved nutrition, and cleaner water rescue children whose bodies would previously have failed under infection or gastrointestinal disease. Neonatal care pushes survival into territories once thought impossible. The result is not merely emotional or demographic, though it is certainly both. It is evolutionary in the strict sense that more inherited variation now survives the early gauntlet of life. Selection through childhood mortality weakens wherever medical systems are strong enough to intervene. That does not mean all differences vanish, because access is unequal and disease burdens remain uneven across the world. But the old pre-medical filter loses much of its direct force. Infectious disease tells the same story on a wider scale. The human past is full of deaths from microbes that are now preventable, treatable, or at least manageable: tuberculosis, wound infections, pneumonia, puerperal fever, plague, cholera, smallpox, and countless local endemic illnesses once shaped entire populations through repeated mortality. Public health and medicine do not erase pathogens, but they reduce exposure, shorten illness, improve survival, and protect those who would have been most vulnerable. Clean water, sewage removal, vaccination campaigns, vector control, quarantines, antibiotics, and safer childbirth environments all combine to create something human history had rarely seen: a large-scale weakening of microbial selection in some populations. Scholars still debate the extent to which this alters long-term evolutionary trajectories, because pathogens continue to evolve, and because modern medicine itself generates new pressures, such as antibiotic resistance and changed immune environments. But no single explanation fully accounts for modern human survival without placing medicine near the center. It is important, though, not to turn this into a fantasy of total rescue. Medicine does not act equally on all bodies or in all places. A child born in one region may have immediate access to sterile surgery, vaccination, and intensive care. Another may still face the older world of contaminated water, undernutrition, unmanaged childbirth, and untreated infection. Even within technologically advanced societies, poverty, discrimination, unequal access, environmental burden, and chronic stress create very different biological realities. The ancient filter is weakened in some settings and remains brutally active in others. This unevenness matters because human evolution is global, not confined to the most protected pockets of the world. The modern species lives across gradients of medicine, infrastructure, and exposure, and those gradients continue shaping survival and reproduction in ways that are difficult to compress into one clean narrative. Still, the broad historical break is unmistakable. For perhaps the first time, large numbers of humans can survive not because their bodies solve a problem internally, but because institutions solve it externally. An appendix that would once have ruptured and killed is removed in time. A bacterial infection that would once have spread to the bloodstream is halted by antibiotics. A fractured femur, historically a devastating injury, can be stabilized surgically. Teeth can be repaired rather than lost. Eyes can be corrected rather than left blurred. Hormones can replace failing endocrine function. Organs can sometimes be transplanted. Each intervention may seem separate, but together they amount to a redefinition of what bodily inadequacy means. A trait that once sharply limited reproductive chances may become almost irrelevant if society builds an effective enough bridge over it. And yet medicine does not suspend inheritance. It changes which inherited tendencies are buffered and which remain exposed. A condition that is survivable with treatment may still influence fertility, development, or later health. A trait protected in childhood may carry costs in adulthood. New reproductive technologies may alter which individuals can have children and when. Survivorship itself changes the population by preserving bodies that earlier eras would have filtered out. But the preservation is part of the environment now. It becomes another force with evolutionary consequences, not a cancellation of them. This is the point that often gets lost. When medicine interrupts selection, it does not remove evolution from the human story. It modifies the pathways through which evolution operates. There is also the matter of mismatch between medicine and the body's older design assumptions. Human immune systems develop in environments of microbial exposure very different from those of heavily sanitized societies. Survival into old age reveals chronic diseases that were less visible when many died young. Treatments keep people alive long enough to experience conditions that are themselves partly shaped by age, diet, stress, pollution, and sedentary behavior. The body once selected mainly to make it through early and middle life now inhabits societies where many live far beyond the ages most relevant to traditional natural selection. That extended lifespan changes the experience of being human, though its evolutionary impact is more complicated because late-life survival matters differently than survival before or during peak reproductive years. Even here, the medical age changes the landscape without making biology irrelevant. Public health deserves special attention because it acts not on individuals one at a time but on whole populations. Clean water systems, food safety, waste removal, vaccination programs, maternal care, workplace protections, and disease surveillance all reduce mortality before doctors ever begin treatment. This is medicine in its broadest and perhaps most powerful form, the redesign of the collective environment so that bodies are less likely to be pushed toward crisis in the first place. From an evolutionary perspective, public health is another giant buffer. It removes hazards that once acted directly and indiscriminately. A contaminated well no longer kills the same way if water is treated. A crowded maternity ward no longer spreads fatal infection the same way if hygiene is enforced. Fewer people die for reasons rooted in inherited vulnerability alone because the environment has been made less lethal. Here the impression that physical evolution has stalled becomes strongest. If childbirth is safer, childhood is safer, infection is safer, injury is safer, and chronic conditions are more survivable, then the body appears to matter less. What counts now is not whether a pelvis, immune response, or metabolism is naturally sufficient, but whether medicine can compensate, and in many cases it can. That is the triumph. It is also the source of the confusion. People mistake reduced selection on certain traits for the end of selection altogether. They see one of evolution's harshest historical mechanisms being interrupted and conclude that the evolutionary process itself has been switched off. But medicine also creates new selective landscapes. Individuals surviving with inherited conditions may still differ in reproductive timing, fertility, and family size. Populations with access to modern care may see older pressures weaken while new ones emerge through diet, pollution, delayed childbirth, endocrine disruption, and chronic disease environments. Assisted reproduction changes who can reproduce. Prenatal screening changes reproductive decisions. Survival with chronic illness alters demographic patterns. What survives in the record suggests not an end to human evolution, but a transfer of pressure from open raw mortality to mediated, socially structured, technologically filtered forms of life. The body is still being sorted, but by a world in which care itself has become part of the ecological setting. There is also an uncomfortable moral shadow to the discussion. The claim that medicine interferes with natural selection has historically been abused by cruel and pseudoscientific movements that equated survival with worth and treated vulnerability as something society ought not protect. That view is not only morally grotesque, it also badly misunderstands human evolution. Humans have always survived partly through cooperation, care, and buffering the weak. Medicine is not a betrayal of the species. It is one of the species' deepest tendencies brought to extraordinary technical power. The relevant question is not whether saving lives is somehow unnatural. It is how saving lives changes the biological pressures acting across generations. That question can be asked clearly without surrendering to inhuman conclusions. By this point in the story, the old prehistoric filter is no longer simply softened. In many contexts, it is actively interrupted by institutions powerful enough to rescue bodies from dangers that shaped most of human history. This does not make the body obsolete, but it does make raw physical robustness a less obvious determinant of survival than it once was. The human organism is increasingly carried by systems outside itself. A weak eye is corrected, a dangerous birth is managed. A vulnerable infant is incubated and fed. A broken bone is set with steel. A failing heart is monitored by machines. If people begin to feel that evolution must have lost its old grip, it is because the evidence of medicine is so visible and so overwhelming. And once medicine joins a larger world of machines, engines, climate control, digital tools, and mechanical labour, the illusion grows stronger still. It is one thing for a body to be rescued when it fails. It is another for a body to be asked to do less of what once defined human survival in the first place. That is the next shift, the age in which humans not only survive weakness more often, but increasingly outsource strength, endurance, and environmental mastery to technology itself. Long before the modern body becomes softer in any moralized sense, it becomes less necessary as a machine for solving the raw mechanics of survival. That is one of the deepest transformations in the human story. For most of prehistory and much of history, the body must move itself across distance, carry its own weight and tools, endure weather directly, lift, grind, haul, dig, climb, fight, and recover without much external help. Survival does not merely happen inside the body, but it depends on the body performing an enormous amount of work. Muscles matter, endurance matters, tolerance for cold, heat, hunger, and fatigue matters. A body that fails physically is often a body whose life narrows fast. Then machines begin taking over, not all at once, not equally, not for everyone, but with growing force. Wheels turn where shoulders once strained. Animals pull loads later replaced by engines. Water is pumped. Grain is milled mechanically. Elevators remove stairs. Vehicles erase distance. Climate control softens the air. Screens mediate work that once demanded direct manual engagement with the world. The human organism remains biologically ancient, but the world around it increasingly performs the labour it once had to do alone. This is another reason people suspect physical evolution has stalled. If technology keeps asking less of the body, then it seems to follow that bodily traits should matter less and less. A person with relatively low endurance can still travel farther in a day than a prehistoric hunter ever could, because the work is done by fuel and machinery. A person poorly adapted to heat can move through summer inside cooled interiors and vehicles. A person with reduced strength can live independently because doors open automatically, goods are delivered, and tools multiply force. Urban life in particular turns physical challenge into an infrastructure problem. Stairs can be replaced. Heavy loads can be rolled. Darkness disappears under electric light. Distance collapses beneath transport networks. The body still exists, but it often feels less like the primary engine of life and more like the passenger. Yet this outsourcing of strength is not just convenience. It changes the adaptive relationship between human beings and the world in ways that are easy to underestimate. In an earlier age, a body incapable of sustained walking, lifting, carrying, and exposure might simply be unable to participate fully in daily survival. In a highly technological society, those exact limitations may have little bearing on whether someone finds food, mates, shelter, or social standing. Many weaknesses once selected against directly are now cushioned by design. The built environment becomes a prosthetic species-wide support system. Roads, plumbing, power grids, refrigeration, engines, and digital communication all extend human capacity while reducing the need for specific forms of physical robustness. The body is still alive at the center of the system, but the system does much of the work that once shaped the body generation after generation. Transport is one of the clearest examples. Human beings evolved as movers across landscapes. Walking, running, carrying, tracking, climbing, balancing, and recovering from long exertion are built into the species' deep history. Even after agriculture and settlement, daily life in most societies still demands substantial bodily movement. Then transport technology compresses the world. First through carts, ships, riding animals, and roads. Later through rail, automobiles, aircraft, and dense urban transit. Distance becomes less a test of the organism and more a question of access. A person can cross a continent without developing the endurance once required to cross a valley on foot. A body that would have struggled in a migratory world can flourish in a motorized one. Selection tied to locomotion does not disappear absolutely, but its force diminishes wherever machines dominate movement. The same logic applies indoors. Climate control is perhaps one of the least dramatic and most consequential modern inventions. The human body is exquisitely vulnerable to temperature extremes. Without shelter, fire, clothing, and later heating or cooling systems, many environments are simply punishing. Air conditioning, central heating, insulated architecture, and sealed interiors create pockets where the old environmental demands are partially suspended. This is not merely comfort. It is a redefinition of habitat. A body no longer has to solve the local climate in the same direct way if a thermostat can mediate between skin and season. The body still sweats, shivers, dehydrates, and overheats when systems fail. But for many people, those failures are exceptional rather than ordinary. It becomes harder to imagine climate as a selector when climate has been folded into infrastructure. Food technology pushes the change further. Refrigeration, preservation, global transport, industrial agriculture, packaging, and instant distribution mean that many modern humans obtain calories with almost no direct physical effort. This is historically extraordinary. The body that evolved amid scarcity, uncertainty, and metabolic vigilance now moves through environments where food can be abundant, engineered, and continuously available. In one sense, this weakens selection for traits connected to enduring hunger or efficiently extracting calories from difficult food. In another, it generates a completely different pressure field involving obesity, insulin regulation, cardiovascular burden, and long-term metabolic disease. Scholars still debate how strongly these modern conditions shape reproductive outcomes versus simply later life health. And the evidence remains incomplete because many effects play out over decades and under unequal social conditions. But the broad pattern is obvious enough. Technology removes one kind of pressure while often creating another. Machines also transform labour. The body no longer needs to grind grain by hand, pump water from a well, chop all heating fuel, or physically haul every object required for daily life. Industrialization takes work out of the body and redistributes it through tools, engines, factories, and energy systems. This does not mean work becomes easy. Many industrial jobs are brutally taxing, repetitive, and dangerous. Some bodies are broken by machinery as earlier bodies were broken by field labor. But the overall arc bends toward externalized force. Human productivity becomes increasingly detached from individual muscular capacity. A person may command enormous material power, not through bodily strength, but through access to machines and systems. In evolutionary terms, this means raw strength may matter less to survival and status than it did in earlier settings, at least across large parts of society. There is a subtler consequence as well. Once technology consistently compensates for bodily weakness, social meaning begins to detach from physical performance. Prestige, mating opportunity, and reproductive success may become less tied to direct bodily competence and more tied to wealth, education, communication, institutional position, or control over technological resources. This does not eliminate attraction to physical form or the practical value of health. It simply shifts the landscape in which bodies are judged. A physically formidable person in a technological society may hold less reproductive or social advantage than a less robust person with greater access to information, money, or networks. That is a profound reorganization of what kinds of traits influence lineage continuity. The body matters, but it matters within a hierarchy increasingly structured by abstraction. Digital technology sharpens the pattern to an almost surreal degree. Human beings now perform economically valuable tasks while sitting almost motionless, moving only fingers and eyes across luminous surfaces. The species that once traversed open ground, manipulated tools through direct contact with wood, stone, fiber, hide, or metal, and calibrated itself against weather, hunger, and terrain, can now spend entire days working inside informational environments detached from immediate physical challenge. The body's still there, of course, aging in the chair, straining its neck, weakening through inactivity, misfiring in appetite and sleep cycles, but it is no longer the obvious site of productivity. In some professions it seems almost incidental. This intensifies the sense that physical evolution must have become irrelevant. If success depends on cognition, social fluency, symbolic manipulation, or digital access rather than endurance or strength, then the old bodily filters appear to have faded into the background. And yet the body does not vanish just because labour becomes sedentary. It begins to express strain differently. Backs ache under prolonged sitting. Eyes adapt poorly to endless near work and artificial light. Sleep rhythms are disturbed by screens and schedules. Muscles lose mass. Metabolic systems operate in environments of low activity and high calorie availability. Cardiovascular stress accumulates silently. The human frame, built for movement, becomes a host for novel chronic burdens. This is one of the great ironies of technological buffering. It rescues the body from certain ancient demands while exposing it to mismatches the old world rarely produced in the same form. The problem is no longer whether a person can carry enough food across a landscape. It is whether a body designed for one pattern of exertion and rest can remain healthy under another that is historically unprecedented. No single explanation fully accounts for how these technological shifts affect evolution, because the pathways are complicated. Many chronic conditions appear after peak reproductive years and may therefore exert limited direct selection. Others influence fertility, pregnancy outcomes, or early family formation more strongly. Social inequality overlays everything. One population experiences technological comfort, while another still performs intense manual labor under dangerous conditions. One person lives in climate-controlled abundance, while another works outdoors in heat extremes or polluted factories. Technology is not evenly distributed, and neither is its buffering effect. This matters because any claim about humans ceasing to evolve physically becomes too simple the moment the global variation comes into view. The species is not living in one modernity, it is living in many. Even so, the broad historical change remains extraordinary. Human beings increasingly inhabit artificial environments where external systems bear much of the burden once carried by anatomy, endurance, and local adaptation. The body is protected, assisted, transported, monitored, corrected, and extended. Weakness is no longer always destiny. A person can compensate for impaired movement, poor vision, low strength, local climate mismatch, or limited manual endurance through the technological surround. That reality makes it tempting to declare that selection on physical traits has largely ended. After all, if the world does not demand those traits the way it once did, why would bodies continue to change in response? The answer, or part of it, lies in remembering that removing one demand does not remove all demands. Technology relaxes old pressures, but it also rearranges life in ways that alter fertility, mate choice, status, development, disease burden, and exposure to new risks. A society organized around machines may reduce the importance of muscle, while increasing the importance of traits linked to metabolism, neurodevelopment, stress regulation, or successful navigation of complex institutions. A climate-controlled world may soften environmental selection while enabling populations to spread into regions where they rely more heavily than ever on infrastructure. A digital economy may diminish the survival value of endurance while making other inherited differences more relevant in opaque ways. The body is not outside the system. It is being sorted by the system's consequences. What technology truly does is make the old visible logic of physical evolution harder to read. In the prehistoric world, the body meets a storm. In the technological world, the body meets a power grid. In the agricultural world, it meets a harvest system. In the city, it meets sanitation and crowd disease. In the medical age, it meets surgical rescue and pharmaceutical buffering. Each step places more of the human survival problem outside the flesh itself. That does not mean the flesh stops evolving. It means the forces acting on it become mediated, delayed, and distributed across environments that humans have built around themselves. By this stage, the case for halted physical evolution can sound convincing because survival seems increasingly detached from bodily quality in the old direct sense. But survival is not the whole story. Reproduction, timing, family size, and long-term biological success still vary across populations and environments, often in ways hidden beneath modern institutions. The old filter may have weakened, but the evolutionary story is not over. It has simply become harder to see because the body is no longer standing alone on open ground. It is entangled with machinery. And that leads to the next, more delicate point. Even if technology and medicine have reduced many traditional forms of physical selection, survival alone has never been the entire engine of evolution. The deeper question is whether the lowering of mortality and the widening of reproductive opportunity truly flatten physical evolution altogether, or whether they simply move it into subtler domains that are easier to overlook. One of the most persistent misunderstandings in this whole discussion is the assumption that evolution is mainly a matter of who dies. Death matters, of course. In the deepest stretches of prehistory and throughout much of history, early death is one of the clearest ways selection acts. If a person dies before having children, or if their children die before reproducing, inherited variation narrows there. But evolution has never been reducible to that one blunt instrument. It also concerns who has children at all, who has more children, when they have them, how many of those children survive, and what environments those children then inhabit. Once that is understood, the claim that lowered mortality must mean the end of physical evolution begins to look too crude for the reality it is trying to describe. Modernity does something strange to the human story. It allows many more people to survive dangers that would once have cut them out of the lineage stream entirely. That is real. Infant mortality falls. Many diseases become survivable. Childbirth becomes safer. Injury is less final. Bodies with vulnerabilities that would have been severe disadvantages in earlier ages can now live long, even ordinary lives. In that sense, one major form of selection does weaken. But survival is only the doorway into the next question. Do all those survivors reproduce equally? Do they do so at the same ages, in the same numbers, under the same conditions, and with the same likelihood that their own children will reproduce? The answer is no, and it has probably never been no at any point in human history. This is where the old image of selection as a brutal external filter starts to fail. In modern societies, selection may act less through immediate bodily catastrophe, and more through patterns of fertility and family formation. Those patterns are shaped by culture so strongly that it can feel almost absurd to discuss them in biological terms. Education, wealth, contraception, social norms, housing, career structures, delayed marriage, urban living, assisted reproduction, religion, policy, and personal choice all play roles. Yet evolution does not care whether differences in reproductive success arise in a dramatic natural landscape or in an apartment tower filled with schedules, aspirations, and economic pressure. If inherited traits interact with those conditions in ways that affect who leaves descendants, then evolution is still present, even if it is almost impossible to isolate cleanly. This is one reason the question remains so difficult. Human beings are now living inside highly cultural reproductive environments. People do not simply mate according to proximity and immediate physical survival. They choose, delay, avoid, plan, negotiate, and revise. They do so within systems shaped by schooling, work, law, medicine, technology, and expectation. The body's old visible role becomes less obvious. A person may survive just fine with physical vulnerabilities that would have been costly in earlier periods, yet reproduce less for reasons connected to stress, status competition, infertility, health, or mate choice. Another may reproduce more not because of unusual bodily toughness, but because their circumstances, preferences, or social environment favor earlier or larger families. The transmission of genes continues, but the pathways are obscured by the density of modern life. Scholars still debate how much this has changed the pace of human evolution, and for good reason. In some respects, lowered mortality does flatten the sharpest old differences. If nearly everyone survives childhood, then one major sorting mechanism loses force. If medicine rescues many congenital and developmental vulnerabilities, then those differences matter less than they once did for reproductive access. If food is abundant and transport easy, then some forms of endurance become less relevant. But no single explanation fully accounts for reproduction in the modern world, because cultural systems do not act evenly, and inherited traits do not disappear simply because institutions have grown stronger. Fertility itself has biological components: age at puberty, hormone function, reproductive health, predispositions affecting behavior, disease risk, stress response, and many other factors can all interact with modern conditions in ways that subtly influence who has children and how many. There is also the matter of timing, which is more important than it first appears. In many societies, people now have children later than they once did. Later reproduction changes the structure of generations, the opportunity for multiple births, and the interaction between health, fertility decline, and life planning. It also increases the role of medical intervention in helping some people conceive. Assisted reproduction is a particularly striking example of a modern buffer that changes the meaning of reproductive limitation. A body that might once have remained childless due to infertility may now have children through hormonal treatment, in vitro fertilization, or related technologies. This is not a peripheral medical detail. It alters which inherited variations remain in circulation. Just as obstetrics change survival through childbirth, reproductive medicine changes who can enter parenthood at all. At the same time, cultural patterns can overwhelm simple assumptions about fitness. In some modern populations, those with greater wealth and education have fewer children on average, despite often having better health and longer life expectancy. In others, different patterns emerge. High fertility may cluster with poverty, religious commitment, rural life, or limited access to contraception. Migration reshapes all of it. People move between reproductive regimes, carrying genes into environments with very different norms. Children of one generation inherit not only biology, but a transformed social landscape that may change family size again. This makes modern evolution difficult to narrate because the old clean link between physical survival and reproductive success has been replaced by a knot of economic, cultural, and biological influences. But difficulty of interpretation is not the same as absence. There is another subtle point here. Lower mortality may actually increase the amount of inherited variation present in a population by allowing more kinds of bodies to survive and reproduce. In older, harsher environments, some variations are removed quickly. In buffered environments, they persist. That can make populations more genetically diverse in certain respects, or at least less ruthlessly filtered by early death. If so, the long-term effect is not a frozen species but a species carrying more variation forward into the future. Whether and how that variation later matters depends on changing environments. A trait protected for several generations might become important again if conditions shift. A previously neutral trait might become costly under new diets, pollutants, pathogens, or reproductive patterns. Modern buffering does not just relax selection, it stores possibilities. This is one reason extinction of physical evolution is such an overstatement. Even if many of the old bodily tests are weaker, human populations still differ in reproductive output, still face unequal environments, still encounter disease, and still pass inherited variation forward unevenly. The shape of selection may be softer and more statistical, but softness is not the same thing as zero. In fact, one of the most likely modern patterns is that strong visible selection on a few obvious physical traits has given way to weaker, diffuse selection across many traits at once. That kind of evolution is much harder for ordinary intuition to recognize. It does not produce heroic stories, it produces probabilities. There is also a moral and emotional reason people are drawn to the idea that survival is no longer the whole story. It seems humane. It suggests that the old cruelty of nature has finally been overcome, that a species capable of protecting the fragile has risen above the pitiless arithmetic that shaped its ancestors. In one sense, that is true. Human beings have built systems of care powerful enough to interrupt ancient patterns of death. But because the narrative is emotionally satisfying, it can lead to a second and less justified belief that biology itself must now be secondary or nearly irrelevant. That leap goes too far. A caring society changes evolution precisely because it changes the conditions of survival and reproduction. The buffer becomes part of the selective environment. Compassion and selection are not opposites. In humans, they have long been intertwined. The body remains entangled in this modern reproductive landscape in ways that are not always obvious. Chronic illness can affect family formation. Fertility disorders do not strike evenly. Stress physiology matters. Exposure to pollutants can alter reproductive health. Nutrition in childhood affects puberty and adult outcomes. Disease burdens, even when not fatal, can influence development and fecundity. Mental health, social cognition, sleep, and hormonal regulation all intersect with the likelihood of forming relationships and raising children. None of these pathways are simple, and it would be reckless to pretend they add up to one clear formula. The evidence remains incomplete, and many effects are modest, overlapping, or heavily shaped by institutions. But they point in the same direction. Modern selection, if that's the right word in each case, is often quieter because it acts through life trajectories rather than obvious survival crises. What survives in the record suggests that whenever one strong pressure weakens, populations do not drift into evolutionary silence. They move into a new balance of pressures, many smaller, some contradictory, some hidden inside social structures. This is not unique to the modern world. Agriculture already did it. Urban life already did it. Medicine and technology intensify it. The human body is no longer being tested only by whether it can outrun danger or survive infection without help. It is being tested by whether it can function, reproduce, and persist within highly artificial environments that distribute risk unevenly and often invisibly. The old evolutionary drama has not ended. It has migrated into subtler theatres, and this may explain why the popular claim carries both truth and distortion at once. It is true that older forms of physical selection have weakened in many populations. It is true that raw bodily robustness is less decisive for simple survival than it once was. It is true that more people can now leave descendants despite vulnerabilities that would historically have been catastrophic, but it does not follow that physical evolution has stopped. It may instead mean that the body is no longer selected mainly through obvious catastrophes. Selection becomes less theatrical, more entangled with fertility, development, metabolism, and hidden burdens. The decline of one kind of harshness opens the door to another kind of subtlety. This is where the argument turns. If survival alone is no longer the whole story, then the most important biological changes in modern humans may be happening out of sight, not in dramatic new anatomy, but in systems buried beneath the surface. Immune responses, metabolic tolerance, reproductive timing, developmental patterns, and the body's negotiation with modern food, chemicals, and chronic stress may be where evolution continues most actively, precisely because those are the places where modern life still presses hardest. If human evolution has become harder to see, one reason is that many of the most consequential pressures now act beneath the surface. People tend to search for evolution in the outline of the skeleton, in height, strength, face shape, skull size, or some imagined new physical feature dramatic enough to photograph. But the modern world may be selecting more strongly through systems that are less visible in daily life: immunity, metabolism, fertility, development, and the body's capacity to function amid diets, pollutants, pathogens, and rhythms unlike those that shaped most of human history. In that sense, the claim that physical evolution has stopped may be less an observation than a problem of eyesight. People keep looking for change in the wrong places. The immune system is perhaps the clearest example. Human beings have never stopped living in a microbial world, even in societies transformed by sanitation, vaccination, and antibiotics. The body remains in constant negotiation with bacteria, viruses, fungi, and parasites. The terms of that negotiation have changed, but the negotiation itself has not. Some ancient infectious pressures have weakened, others persist. New pathogens emerge, old ones return in altered forms. Dense travel networks spread disease rapidly across continents. Medical intervention saves lives, but it also changes the selective landscape by allowing some immune vulnerabilities to persist, while exposing populations to new combinations of pathogens, treatments, and inflammatory environments. Scholars still debate exactly how much ongoing immune-related evolution is occurring in different populations, because the evidence is complex and often difficult to separate from social and environmental effects. But no serious view of human biology can treat immunity as finished business. What makes immunity especially important is that it operates through countless subtle differences rather than one heroic trait. A slightly different inflammatory response, a somewhat altered reaction to a local pathogen, variation in how the immune system distinguishes friend from threat, differences in resistance, tolerance, recovery, and collateral damage. These are not the kinds of changes that announce themselves in visible anatomy, yet they can influence survival, illness severity, fertility, pregnancy outcomes, and long-term health. They are deeply physical, but not in the dramatic external sense popular imagination prefers. When modern humans ask whether they have stopped evolving physically, they often forget that the immune system is as physical as bone. Metabolism is another hidden frontier. The human body evolved across long periods in which calories were uncertain, diets varied geographically, and large swings between abundance and scarcity were common. Modern food environments are different in scale and speed, almost beyond recognition. Refined sugars, concentrated fats, industrial processing, constant availability, artificial flavor engineering, and global transport create metabolic conditions that did not exist for nearly all of human time. Bodies once shaped to store energy efficiently under threat of famine now move through settings where storage itself can become dangerous. Obesity, insulin resistance, fatty liver disease, and related disorders are not merely lifestyle stories in the shallow moralizing sense they are often presented. They are signs of a body operating under nutritional conditions that exceed the expectations built into much of its earlier history. This does not mean there is one simple evolutionary answer waiting to appear. Modern metabolic disease is profoundly shaped by behavior, policy, inequality, food systems, stress, sleep, and physical activity, as well as inherited variation. The evidence remains incomplete on how contemporary selection may be acting across these traits, and researchers are rightly cautious about drawing large conclusions from short time frames. But what survives in the record of population history already shows that humans can evolve in response to diet. Agriculture changed bodies. Dairying changed bodies. local ecologies changed bodies, there is no reason in principle to think the modern nutritional world should be evolutionarily silent simply because its pressures are mediated through supermarkets and supply chains rather than wild plants and hunted game. If anything, the scale of the new environment makes the question more urgent, not less. Reproduction sits at the center of that urgency because metabolism is never just about body weight or disease in old age. It affects puberty timing, fertility, gestation, fetal growth, lactation, and the health of children who will themselves enter the lineage stream. Childhood nutrition and early life metabolic conditions can shape adult outcomes profoundly. A body built in one nutritional environment may be mismatched to the one it later inhabits. This is one reason developmental biology complicates the whole conversation about modern evolution. Bodies are not simply carriers of genes. They are built through interactions between genes and environments during growth. If those environments change dramatically, the resulting physical form may shift even without immediate genetic change, while still creating new long-term selective pressures. The modern body is being assembled under conditions no Pleistocene child would recognize. Pollution adds another layer. Ancient humans encountered smoke, toxins from certain plants or minerals, and natural environmental hazards, but they did not inhabit a world saturated with synthetic chemicals, fine particulates from industrial combustion, endocrine disruptors, plastics, heavy metals in complex urban systems, and persistent manufactured compounds dispersed through air, water, soil, and food. This is one of the least intuitive and most unsettling parts of modern physical existence. The body is navigating substances for which there has been little or no deep evolutionary preparation. Some exposures damage fertility, some alter development, some affect immune function, hormone signaling, cognition, or cancer risk. Not all of these pressures translate neatly into selection, and many act too diffusely or too late in life to produce obvious evolutionary signatures quickly. But they are still bodily realities, and over enough generations they may shape which physiological configurations prove more resilient than others. Fertility itself is another domain where hidden evolution may be unfolding. Human beings often think of fertility as either a private medical issue or a social choice. But biologically it is a landscape of hormones, gametes, developmental timing, immune tolerance, uterine environment, sperm quality, and genetic compatibility. Modern conditions alter all of these through stress, nutrition, chemical exposure, disease, delayed parenthood, and medical intervention. Some people reproduce only with assistance. Others remain childless not because of obvious bodily frailty, but because subtle biological and social factors combine against reproduction. If inherited differences influence how bodies navigate these modern, reproductive environments, then evolution is still operating through the most ancient channel it has always used. The route is simply more obscured by culture and medicine than it once was. The same is true of development. Human growth is extraordinarily plastic. Height, body composition, puberty timing, and aspects of anatomical form are shaped not only by genes, but by childhood disease burden, nutrition, sleep, stress, and workload. Over the last few centuries in many populations, average height has increased substantially under improved nutrition and reduced childhood disease. That is not necessarily evolution in the strict genetic sense. Much of it is developmental response. But developmental plasticity matters because it reveals how strongly the body still responds to environment. It also complicates claims about physical stasis. A species can look different across time not only because its genes have changed, but because its developmental conditions have. And once environments shift development persistently, they may also begin shaping evolutionary outcomes in turn. One of the stranger modern examples is the possibility that some of the most important changes are happening in tolerances rather than abilities. Earlier human evolution may have often rewarded direct capacities tolerating altitude, digesting a new food source, resisting a local pathogen, regulating heat in a harsh climate. Modern life may instead be selecting for tolerances to chronic low-level burden sedentary living, artificial light, endocrine disturbance, inflammatory diets, psychological stress, reduced microbial diversity, or exposure to urban pollutants. These are not glorious adaptations. They are not the stuff of heroic prehistory. But they may be exactly the kind of hidden bodily negotiation that now matters most. The modern body is less likely to be asked whether it can kill a large animal with a spear. It is more likely to be asked whether it can remain reproductively functional, metabolically stable, and immunologically balanced inside a chemically altered, chronically stimulating, and often sedentary world. This is one reason the phrase "stopped evolving" physically collapses under scrutiny. It assumes that physical evolution must announce itself through visible structural change. But a liver is physical, a pancreas is physical, hormone signaling is physical, placental function is physical, the immune response to a virus is physical, the timing of puberty is physical. The capacity to maintain fertility in a polluted environment is physical. If these are the traits under pressure, then physical evolution has not ended. It has become less theatrical and more internal. The body is still changing, only not always in ways that create a new silhouette. There is also the problem of timescale. Many of the hidden pressures of modern life are very recent: industrial chemical exposure, mass-processed food consumption, digital light environments, and highly sedentary labour patterns are in many cases only a handful of generations old. That may be far too short a period for strong, widespread genetic changes to become obvious, especially in large, mobile populations with extensive mixing. The absence of dramatic evidence so far does not prove the absence of ongoing selection. It may simply reflect that the experiment is still underway. What survives in the record suggests that humans have repeatedly taken culture into new territory, and then discovered, often painfully, that bodies take longer to adjust than inventions do. And perhaps that is the most important shift in perspective. When people say scientists think humans stopped evolving physically, they often imagine the body as a finished tool now shielded by civilization. But the better image may be of a body still under negotiation, still being tested, only by forces that are distributed through blood sugar, inflammatory load, chemical exposure, fertility patterns, and disease ecology rather than teeth, claws, and winter cold alone. The modern body is not standing outside evolution. It is standing inside an environment whose pressures are diffuse, internal, and cumulative. That makes them easy to ignore until they accumulate into whole landscapes of illness or difference. If so, then the modern human story is not one of evolutionary silence but of evolutionary concealment. The old bodily drama played out in the open world. The new one is often buried in tissues, developmental pathways, and statistical patterns that require entire scientific fields to detect. And once that possibility is taken seriously, another unsettling thought follows. The body may not merely be changing slowly under modern pressures. It may also be carrying visible signs that it is still badly mismatched to the world we've built signs so ordinary that they barely register as clues at all. If the modern body really had stopped evolving in any meaningful physical sense, one might expect it to fit its world with a certain quiet competence. Not perfectly, because evolution never produces perfection. but well enough that the ordinary features of daily life would not seem to grind so constantly against the organism itself. Instead, the opposite often appears true. The modern body is full of friction. It hurts in repetitive ways. It fails in familiar places. It carries old compromises into new settings and reveals, almost by accident, how incomplete the fit still is. That friction may be one of the strongest clues that humans are not finished products at all, but creatures living inside a mismatch so broad that it has become ordinary. Take the human spine. Upright posture is one of the signature features of the species, but it comes at a cost. The spine is not a flawless architectural column designed for long days in chairs, vehicles, and soft furniture. It is an evolved structure built through compromises between balance, movement, load-bearing, childbirth, and the inherited legacy of a body that once moved on 4 limbs. Lower back pain is so common in modern societies that it can seem like background noise rather than evidence. Yet it is evidence of something important. The human back functions well enough for most people to survive and reproduce, which is all evolution ever strictly requires. But it is far from ideal for the environments many bodies now inhabit. Sedentary work, repetitive lifting, weak supporting musculature, and long static postures all expose design tensions that were always there. The body did not stop evolving because it was perfected. It may simply not have had time, pressure, or the right conditions to resolve those tensions. The knee tells a similar story. Walking upright across varied terrain is one thing. Living on flat, hard surfaces, climbing stairs in built environments, carrying modern body weights, and oscillating between long sitting and bursts of movement is another. Knees fail not because they are useless, but because they are joints managing enormous forces within anatomical limits, never custom-built for every modern pattern of use. Pain, degeneration, injury, and instability are not rare anomalies. They are widespread reminders that a functioning organism is not the same as an optimized one. If anything, the commonality of these problems suggests that survival with imperfect design remains entirely possible in a buffered world. Medicine, surgery, braces, replacements, and pain management carry the body forward without requiring anatomy itself to solve the issue. Teeth may be even more revealing because they preserve both evolutionary legacy and developmental mismatch in one small, crowded space. Human mouths are strangely overambitious. Wisdom teeth erupt into jaws that often do not have room for them. Crowding, impaction, infection, and removal have become so familiar that they scarcely seem mysterious anymore. Yet they point directly toward a body that has not been tidied into a final form. Some of this may reflect developmental change related to softer diets and reduced chewing demands rather than purely genetic evolution, and scholars still debate the balance between inherited jaw size, childhood mechanical use, and broader population shifts. But whatever the mixture, the result is telling. The modern human face often develops in ways that reveal a mismatch between ancient dental equipment and recent conditions. The body is carrying hardware from one world into the habits of another. Vision offers another striking case. Nearsightedness has become common, in some places startlingly common, especially in populations where childhood is spent indoors, under artificial light, and focused on near work rather than distant outdoor viewing. Much of this appears to be developmental and environmental rather than a simple story of rapid genetic change. Yet that is part of the point. The body is highly responsive to conditions, and those conditions can create widespread physical trouble without any need for dramatic inherited transformation. Myopia is not proof that humans have stopped evolving. It is proof that the organism can be thrown off balance by environments unlike those in which many of its systems took shape. The eye, like the spine and jaw, becomes a small daily witness to mismatch. Then there is childbirth, perhaps the most intimate and sobering sign that the human body remains a bundle of unresolved compromises. Upright walking narrows and reorients the pelvis. Large brains enlarge the infant head. The result is a birth process that is often difficult even under favourable conditions and historically dangerous on a massive scale. Modern obstetrics has softened the danger tremendously in many places, but the underlying anatomical compromise has not vanished. A species that had truly stepped beyond bodily constraint might be expected to have resolved one of its central reproductive hazards more neatly. Instead, humans survive it through assistance, technology, and collective care. The tension remains written into the skeleton. The body is not failing to evolve because childbirth is still difficult. It is showing how evolution often settles for good enough under one set of trade-offs, leaving later societies to buffer the consequences. Metabolic disease may be the most pervasive mismatch of all. Appetite, reward, energy storage, and hunger regulation evolved under conditions where calories were uncertain. Highly processed food did not exist, and physical activity was embedded in survival. Modern environments invert that logic. Calorie-dense food is cheap and continuous. Physical exertion can be optional. Sleep is disrupted. Stress is chronic. Under those conditions, many bodies store too much, regulate poorly, and drift toward diabetes, cardiovascular strain, and related disorders. It is tempting to describe this in moral language, as though individual discipline were the whole explanation, but that misses the deeper biological story. The body is revealing that its ancient metabolic assumptions do not map smoothly onto industrial food worlds. This is not evidence of stasis. It is evidence that the organism is under pressures it has not yet fully accommodated and may not accommodate quickly. Even the immune system can look mismatched in the modern world. In some settings, reduced exposure to the microbial diversity of earlier environments may contribute to allergies, autoimmune disorders, and inflammatory misfires, though the exact mechanisms are still debated and no single explanation fully accounts for the rise of these conditions. What matters here is the broader pattern. The body does not simply struggle when danger is too severe. It can also struggle when its regulatory systems are tuned for one ecological context and forced to operate in another. Too many pathogens kill. Too few of the older microbial signals may also cause trouble. The immune system, like metabolism, is not static. It is calibrated, and calibration can go wrong when the environment changes faster than the body's inherited expectations. Sleep and circadian rhythm belong in the same category. The human body evolved under cycles of daylight, darkness, seasonal variation, physical exertion, and social rhythms very different from those of modern electrified life. Artificial light extends activity deep into the night. Shift work detaches labor from solar time. Screens compress stimulation into hours once governed by dimness and rest. The result is not merely tiredness. Hormones, appetite, mood, fertility, cognition, and metabolic regulation all intersect with disrupted sleep. Once again, the body appears less like a completed design and more like an organism carrying ancient timing systems into a world that ignores them. This tension is so commonplace that it can feel trivial, yet at scale it reveals a species operating under constant low-level contradiction between inherited biology and built environment. What makes these clues powerful is not that they prove one clean evolutionary pathway. They do not. In many cases, the visible problems of the modern body are developmental, cultural, or environmental far more than they are evidence of recent genetic change. but that itself matters. It shows that the body remains plastic, vulnerable, unfinished, and deeply contingent on context. A species that had truly become independent of physical evolution might be expected to function smoothly so long as technology was present. Instead, modern humans rely on dentistry, obstetrics, eyeglasses, ergonomic redesign, physical therapy, pharmaceuticals, and surgery just to manage ordinary bodily strain. Technology does not only extend the body, it often compensates for how poorly the body fits the environments technology has created. Scholars still debate which of these mismatches may eventually produce stronger selection, and which may simply remain chronic burdens buffered by medicine and social systems. Many modern ailments arise after peak reproductive years, and therefore exert only limited direct evolutionary pressure. Others affect fertility, pregnancy, childhood development, or long-term reproductive success more substantially. The evidence remains incomplete because the timescales are short and because human lives are now so entangled with institutions that it is difficult to isolate inherited effects from policy, inequality, behavior, and chance. But the mismatches themselves are unmistakable. They show that the human body is not a finished object resting comfortably in the modern world. It is a historical compromise surrounded by support systems. That may be the strangest case of all. People often say humans have stopped evolving physically because they see a world in which technology saves weak bodies. But the same world is also full of clues that even the ordinary healthy body is under strain. It sees badly at certain distances, aches in chairs, labours awkwardly in childbirth, mismanages calorie abundance, responds imperfectly to sanitized environments, and drifts out of sync with artificial time. This is not the profile of a species that has transcended embodiment. It is the profile of one still carrying ancient architecture through newly invented conditions. And if the body is still unfinished in so many obvious ways, then another possibility opens. Evolution may not only continue through hidden physiological systems or diffuse fertility patterns, it may also still be shaped, as it long has been, by the deeply human realm of attraction, partnership, status, and mate choice. Survival may matter less visibly than before, but the question of who pairs with whom and why has never disappeared. If anything, in a world where raw survival is buffered, the role of sexual selection may become harder to ignore. Long before human beings built cities or hospitals, survival alone was never the only force shaping the species. People did not merely endure environments, they chose one another within them. They formed bonds, competed for status, signaled health, judged reliability, displayed skill, and moved through social worlds where attraction could shape lineage just as powerfully as cold or hunger. This older force does not vanish when medicine and technology soften the rawest pressures of natural selection. If anything, it becomes more visible once survival itself is less decisive. In a world where many more bodies live long enough to reproduce, the question of who is chosen, who pairs successfully, and under what conditions may matter more, not less. Sexual selection is often misunderstood because it is imagined too narrowly. People reduce it to beauty, ornament, and simple preference, as though the whole story were written in faces and body shapes alone. But in humans it has always been more complicated. Attraction may include physical appearance, but also voice, movement, scent, symmetry, confidence, emotional regulation, status, generosity, intelligence, humor, kin ties, resource access, and the ability to function well within a social group. Different societies value different combinations. preferences vary across place, class, circumstance, and era. Scholars still debate how much universal pattern exists beneath this variation, because the evidence remains incomplete, and culture is never a thin layer laid over biology. It saturates courtship from beginning to end. Yet that does not make sexual selection unreal. It makes it deeply human. In earlier worlds, attraction and survival were more tightly intertwined. A strong, reliable, socially integrated person could be a better partner, not because of abstract ideals, but because food, protection, labour, and child survival depended on cooperation under severe conditions. Physical robustness likely carried clear value in many settings, though never in isolation from trust, skill, reputation, and kin networks. A reckless hunter with a violent temper may have been less desirable than a steadier person with better judgment. A graceful storyteller or skilled craftsperson could matter more to group life than a merely imposing physique. Even then, mate choice did not reduce to raw bodily power. Humans have always selected through a richer social lens than that. Modernity changes the lens but does not remove it. Once technology, infrastructure, and medicine reduced the direct importance of strength, cold tolerance, hunting skill, and wound survival, other traits may become more central in partner choice. Economic security, education, emotional stability, social fluency, ambition, and symbolic status can outweigh physical toughness in many settings. That is a profound shift. It means the body may no longer be favoured chiefly for the traits that kept it alive in open landscapes, but for traits that help it succeed inside dense, abstract, culturally elaborate societies. Some of those traits may have biological components. Many are heavily shaped by upbringing and institutions. Most are some mixture of both. The point is not that modern mate choice is secretly genetic destiny. It is that lineage continues to be shaped by preferences, and preferences have consequences. Physical appearance still matters, of course, but even here the story is not simple. Human beings remain sensitive to cues that may loosely correlate with youth, health, fertility, symmetry, hormonal profile, or developmental stability. Yet culture continuously reshapes how those cues are read. Body size can signal abundance in one context and poor health in another. Skin tone, hairstyle, musculature, height, facial structure, and dress acquire meanings that are never merely biological. Fashion and media amplify some traits and suppress others. Cosmetic technologies further complicate the picture, allowing bodies to alter presentation in ways that blur the line between inherited form and crafted appearance. If sexual selection is still operating here, it is doing so through signals increasingly filtered by culture, commerce, and self-staging. The body is still involved, but rarely in naked prehistoric terms. Height offers a useful example. In many societies, taller men have often enjoyed certain social and mating advantages, though these patterns vary and are never absolute. Height is influenced by many genes, but also strongly by childhood nutrition, disease burden, and overall developmental conditions. So when height matters in attraction or status, biology and environment are already fused. A population that grows taller under improved childhood conditions may alter social preferences, which then feed back into partner choice. Yet this does not automatically translate into straightforward genetic selection for greater height, because modern reproductive patterns are shaped by education, delayed marriage, contraception, and socio-economic structure in ways that may counteract or scramble those preferences. What appears simple at the surface dissolves into complexity the moment it is examined closely. The same is true of facial features, body composition, and markers of perceived attractiveness. People may favor traits that loosely signal health or fertility, but those signals exist in environments transformed by dentistry, skincare, grooming, nutrition, surgery, cosmetics, and digital image culture. A modern face is never just a face. It is a biological form shaped by development and ancestry, then modified by care, class, technology, and presentation. This means that even if sexual selection remains active, it does not operate on untouched anatomy. It operates on bodies embedded in industries and institutions that can amplify, disguise, or simulate inherited cues. That makes ongoing physical evolution through mate choice harder to read, not necessarily weaker in principle. There is also the question of assortative mating, one of the quieter but more important patterns in modern populations. People often pair with others who resemble them in education, values, class background, religion, region, and increasingly in certain behavioral or cognitive profiles. Some of this has biological implications because many psychological and developmental traits have partial heritable components. If increasingly pairs with inherited differences can become clustered rather than evenly mixed. The consequences for long-term evolution are difficult to predict, and scholars remain cautious, but the process matters because it shows how cultural sorting can reshape the transmission of biology without any dramatic natural ordeal. A modern city, a university system, or an online dating landscape may influence who reproduces with whom as profoundly as geography once did. Sexual selection also includes competition, though again not always in obvious physical forms. In older settings, dominance, coalition strength, and bodily prowess may have played more visible roles in some contexts. In modern societies, competition is often displaced into career success, status display, education, charisma, social networks, and control of resources. These can affect partnership prospects even when the body itself is not especially formidable. From an evolutionary perspective, this means reproduction may be shaped by success in symbolic and institutional arenas rather than direct physical contest. If inherited traits contribute even modestly to how people navigate those arenas, then mate choice and differential reproduction may continue shaping human populations in ways that are real but deeply entangled with culture. No single explanation fully accounts for how modern sexual selection works, because the pressures are often contradictory. One society prizes thinness, another robustness. One social world favors delayed childbearing and intensive partner screening. Another emphasizes early family formation. Some contexts reward high status but low fertility. Others reward pair stability over attractiveness. Some individuals with strong mate market advantages choose not to reproduce at all. Others with fewer obvious advantages have large families, gender norms, contraception, law, religion, and economic precarity all alter the landscape. What survives in the record suggests only that human mating is a major driver of lineage distribution, not that it obeys one universal simple rule. Still, the broader implication is hard to avoid. If natural selection through mortality has weakened in many places, sexual selection and socially structured reproduction may account for a larger share of the visible evolutionary process than before. That does not mean the human future will be sculpted into obvious beauty stereotypes or status caricatures. It means that in a buffered world, who chooses whom may matter more relative to who merely survives. The ancient body once had to win against climate and infection before attraction could even enter the story. The modern body, more often rescued from early death, may find that attraction, compatibility, and social success play a larger role in determining which inherited variation continues. This is especially striking because it preserves continuity with the past even as conditions change. Humans have always been a species in which social life mediates biology. People do not reproduce randomly. They never did. Kinship rules, taboos, dowries, alliances, prestige, and desire have long directed the flow of inheritance. Modernity does not invent that pattern. It multiplies its channels. Dating platforms, urban anonymity, educational sorting, labour markets, migration, and shifting norms around marriage all expand the range of who can meet whom and why they might choose one another. At the same time, contraception separates sex from reproduction more effectively than at any previous point in history, meaning that mate choice and actual lineage transmission no longer perfectly overlap. Another complication enters. Attraction remains powerful, but its evolutionary consequences are filtered through deliberate reproductive control. That separation may be one of the most modern features of all. Human beings can now desire, bond, and pair without necessarily producing children. They can also produce children without traditional pair structures through donor systems, assisted reproduction, and other technologies. This does not abolish sexual selection, but it changes its relationship to reproduction in historically unprecedented ways. Some attractive traits may spread socially without spreading genetically. Some lineages may continue through medical systems rather than ordinary pair bonding. The environment of choice grows thicker, stranger, and more mediated. Yet the underlying question remains ancient: which bodies, in combination with which social pathways, actually leave descendants. By now it should be clear why the phrase humans stopped evolving physically keeps slipping out of focus. Even in realms where bodies appear less central than before, such as modern mate choice shaped by institutions and culture, physicality remains in the story. Hormones, development, fertility, facial form, stature, voice, gait, stress tolerance, and health all influence attraction and reproduction, though rarely in clean isolation. The body has not exited human selection. It has become entangled with symbolic life so completely that the threads are difficult to separate. And that entanglement points toward an even larger truth. Human evolution now unfolds in real time through the constant feedback between biology and culture. Genes affect bodies. Bodies move through invented worlds. Those worlds reshape which genes matter. Migration, urbanization, intermarriage, delayed reproduction, education, medicine, and global exchange feed back into the process continuously. To understand whether humans have stopped evolving physically, it is no longer enough to look at bodies alone. It becomes necessary to look at the loop itself. By this point, the old boundary between biology and culture has almost completely dissolved. Not because genes no longer matter, and not because culture has become some magical force floating free of bodies, but because each now continually rewrites the significance of the other. A human being is born with inherited possibilities, but those possibilities are expressed inside languages, diets, family systems, schools, cities, technologies, medical regimes, climates, labour markets, and migration routes that previous generations would scarcely recognise. The body enters a world already built by other bodies. That world changes what counts as health, danger, fertility, status, and even normal development. If the modern species seems difficult to read evolutionarily, it is because the evolutionary environment is no longer mainly river valleys, predators, and winter camps. It is also apartment blocks, processed food, antibiotics, endocrine disruptors, delayed marriage, global travel, online assortative mating, and childhood under electric light. Genes meet culture in real time, and each makes the other more complicated. This feedback loop is not new in principle. Fire already changed the body's relationship to food and cold. Agriculture already changed disease, diet, and fertility. Cities already altered immunity, labor, and social survival. But the scale and speed of the loop today are without precedent. A cultural practice can spread across continents in years. A dietary pattern can shift within a generation. Migration can bring together lineages separated for long stretches of time, then place their descendants in environments unlike either ancestral setting. Medical interventions can preserve inherited conditions that would once have vanished quickly, while social systems can produce new stressors and new opportunities so rapidly that bodies scarcely seem able to catch up. The result is not an end to evolution, but an evolutionary environment that changes before it can be easily measured. Migration is one of the clearest forces in this modern entanglement. Human populations have always moved, mixed, separated, and mixed again. But global transport intensifies the process. People now cross oceans and continents with regularity, carrying ancestral genetic variation into new disease ecologies, new diets, new social norms, new climates, and new mating markets. Their children inherit combinations of ancestry that earlier geography would rarely have permitted, then develop under conditions different again from those of either parent. This has several consequences. It increases genetic mixing in many populations. It breaks down older regional isolation. It can reduce the likelihood that strong local adaptations remain concentrated within one place. At the same time, it creates entirely new combinations of inherited variation interacting with environments built by industrial modernity. The species becomes more interconnected biologically, just as its environments become more artificial. Urbanization magnifies this further. The modern city is not simply a larger version of the ancient one. It is often a place of chronic artificial light, reduced physical movement, high psychosocial stress, processed food access, pollution, specialized health care, educational sorting, and delayed family formation all at once. In such places, biology and culture do not take turns shaping life. They operate simultaneously. A child's growth reflects genes, but also prenatal care, air quality, diet, infection history, schooling, sleep patterns, family stress, and neighborhood structure. A young adult's fertility or mating prospects reflect hormones and development, but also labor markets, housing costs, digital life, educational matching, and social norms around timing. None of these factors erase physical evolution. They form the modern terrain across which it must travel. Intermarriage and broad population mixing introduce another layer. When previously more distinct populations blend, some local genetic patterns become diluted, others recombine, and new trait distributions emerge. This can reduce the clarity of older adaptive signatures while also increasing the pool of variation from which future selection might act. In simple terms, more mixing can make the species less partitioned and more fluid. But again, fluidity is not stasis. A mixed population is not an unevolving population. It is a population in motion, one whose future biological pathways may be less regionally neat than in the past. The human story becomes harder to narrate through isolated lineages and easier to understand as a dynamic network of inheritance flowing through constantly shifting cultural landscapes. Education and social institutions may seem at first glance too abstract to belong in a discussion of physical evolution. But in modern humans they matter, because they influence reproductive timing, partner choice, family size, stress, health behavior, and developmental outcomes. A schooling system changes when people leave childhood. A labor system changes when they form households. A society organized around long education and delayed economic security changes the age at first birth, and often the total number of births. These are cultural arrangements, but their biological consequences are real. If inherited traits affect how successfully people move through these institutions, then culture becomes a mechanism through which biological differences are sorted. Not cleanly, not deterministically, and never independently of inequality and chance, but enough that the old distinction between natural and social selection begins to look less useful than it once did. Even medicine, which often appears as the great interrupter of evolution, fits into this loop rather than standing outside it. A treatment developed by human ingenuity changes survival. Changed survival alters the distribution of inherited variation. That new distribution then lives inside further cultural environments that create fresh pressures. A person survives with a chronic condition because of medication, then has children later because schooling and work demand delay, then raises those children in a low movement, high stimulation urban setting where different developmental pressures take hold. At every step, biology is being carried through culture, and culture is being built by biology. Neither can be fully read without the other. There is a temptation here to say that culture has become evolution by other means. That is partly right, but only partly. Culture can change environments much faster than genes can track them, and in many cases cultural solutions arrive before genetic adaptation becomes widespread. But culture does not replace inheritance. It rearranges the conditions under which inheritance matters. A population can respond culturally to a challenge, and thereby weaken selection for one trait while intensifying it for another. For example, food abundance created by industrial systems may reduce selection linked to famine resistance, while increasing pressures related to metabolic regulation. Fertility under obesity, or resilience to inflammatory diets. Digital work may reduce the relevance of physical endurance while altering the importance of sleep regulation, stress tolerance, or social cognition. These are not guaranteed outcomes, only examples of the broader principle. The body keeps meeting new environments, and many of those environments are cultural inventions. Scholars still debate how much of modern change should properly be called evolution versus plasticity, demographic sorting, or social stratification. The distinction matters. A population can become taller because childhood nutrition improves, not because genes for greater height rapidly spread. Fertility patterns can change because contraception becomes available, not because inherited reproductive tendencies shift. Disease burdens can fall because sanitation improves, not because immunity has already adapted. The evidence remains incomplete in many areas, and caution is necessary. Yet even these clarifications do not rescue the idea of complete physical stasis. Plasticity itself is part of how bodies respond to environments. Demography determines which lineages expand. Social structures influence who reproduces. Over time, those forces interact with inheritance whether people notice it or not. The modern world also creates a new kind of global experiment in repeated local mismatch. One family line may move from rural scarcity into urban abundance in a generation. Another may move from tropical climate into cold northern air, then inhabit heated interiors and a processed food economy. Another may carry ancestry shaped in one pathogen regime into a completely different microbial setting. Children grow in bodies informed by ancestral histories, but not determined by them, while contemporary conditions push development along new paths. The result is a species constantly improvising between deep time inheritance and recent invention. This improvisation is messy, uneven, and often painful. It leaves traces in chronic disease patterns, fertility shifts, developmental strain, and new distributions of risk. It also makes any clean statement about humans stopping their physical evolution feel increasingly inadequate. What survives in the record suggests that human evolution has become cumulative in a new way. Earlier selective pressures often acted locally and visibly: a climate, a disease, an altitude, a food source, a labour pattern. Modern pressures stack. They overlap rather than replace one another. A body may simultaneously navigate chemical exposure, late bedtime under artificial light, calorie abundance, reduced movement, psychological strain, delayed reproduction, medical buffering, and broad partner choice in a mixed urban population. Each factor alone may exert only modest force. Together they create a dense adaptive fog. The species is still changing within it, but the change does not reveal itself as neatly as the classic stories of pastoralism, altitude, or plague resistance. This is why the modern human condition can feel evolutionarily ambiguous. People sense that technology and culture dominate life more than raw biology does, and they are not wrong. But domination is not erasure. It is transformation. Culture now acts as the medium through which many biological pressures are transmitted. It tells bodies what to eat, when to sleep, how to work, when to reproduce, where to live, what air to breathe, what chemicals to absorb, what diseases to fear, and what kinds of partners are available or desirable. Genes do not stop mattering in such a world. They matter inside an environment whose rules are rewritten continuously by other humans. And that brings the story to one of its strangest turning points. If culture and technology are now powerful enough to shape inheritance indirectly, then what happens when they begin shaping it directly? Once reproduction can be screened, selected, assisted, edited, or technologically managed before birth itself, the future of human physical change may begin to move away, not only from old natural pressures, but from the slow blind pace of ordinary evolution altogether. For most of human history, the future body arrives the same way the past body did, through inheritance shaped by chance, survival, mate choice, local ecology, and the long uneven filtering of generations. Even when culture transforms the environment, genes still move forward by ancient roots. A child inherits a body no one explicitly designed. It may be cared for, taught, healed, and modified, but it is not selected in advance with much precision. That old arrangement is now beginning to change, not everywhere, not completely, and not without ethical limits, legal barriers, and intense public debate, but enough to alter the horizon of the question. If humans seem to be evolving less through obvious natural pressures, it may be because a new possibility has entered the story. Future humans may change differently, not because evolution has stopped, but because technology is learning to intervene before evolution has time to act. The first signs of this shift are not usually dramatic in appearance. They begin in clinics and laboratories, in fertility treatment, genetic counseling, embryo screening, prenatal testing, donor selection, and the quiet routines of assisted reproduction. These technologies are often used for compassionate and practical reasons. Couples struggling with infertility seek help to have children at all. Families with known severe genetic disorders try to reduce the risk of passing on devastating disease. Pregnancies are monitored for developmental problems. None of this resembles the lurid fantasies that tend to dominate public imagination. Most of it is cautious, limited, and deeply human in motive. Yet even these relatively familiar interventions change the logic of heredity. They allow people to influence which embryos implant, which pregnancies continue, and which inherited conditions are more or less likely to appear in the next generation. That is not the end of evolution. It is a redirection of part of its terrain. Assisted reproduction alone already changes who enters the lineage stream. In earlier eras, infertility often meant the end of a genetic line, however emotionally painful or socially complicated that might be. In vitro fertilization and related techniques alter that outcome. Bodies once excluded from reproduction by sperm count, ovulatory problems, blocked fallopian tubes, timing, or other biological barriers can now produce children. As with medicine more broadly, this buffers ancient forms of selection, but it also creates new patterns. The timing of reproduction shifts later. The importance of reproductive technologies rises. Medical access becomes a new determinant of lineage continuity. What once depended on unassisted physiology now depends partly on infrastructure, cost, expertise, and law. The body's biological limits remain relevant, but they are increasingly mediated by technical systems. Embryo screening makes the shift more explicit. Where it is available, clinicians can in some cases test embryos for certain serious genetic conditions before implantation. This is still a narrow and medically focused practice in most real-world contexts. Far from the fantasy of custom-designed offspring, many traits are too complex, too polygenic, too entangled with environment, or too weakly predictable for any simple selection. Scholars and clinicians are well aware of these limits, and the evidence remains incomplete on what more ambitious attempts at prediction could realistically achieve. But even limited screening matters because it moves choice earlier in the process. Some inherited variations no longer rise or fall only through birth, illness, and lifetime reproductive success. They may be filtered before pregnancy continues. The selective environment shifts from the open world into the reproductive clinic. Prenatal testing extends the same logic, though with different moral and legal implications depending on country, culture, and personal conviction. Prospective parents can learn certain information about a fetus before birth that earlier generations could not have known. This knowledge can shape preparation, medical care, and, in some circumstances, decisions about whether a pregnancy continues. That is one of the most sensitive areas in the entire subject because it lies where biology, ethics, law, disability, parental fear, and cultural values meet. It must be handled carefully. The point here is not to flatten that complexity into a cold evolutionary mechanism. It is to note that as information moves earlier, inherited traits increasingly encounter human judgment before the old filters of life and death ever apply. Future bodies may be shaped not only by which children survive, but by which possible children are brought into the world at all. Gene editing raises the question to its most dramatic form, even though its present practical use in humans remains limited, contested, and heavily constrained. The idea that inherited traits might one day be altered directly before birth has a powerful hold on public imagination. It sounds like the final escape from blind evolution, no more waiting for gene frequencies to drift over generations, no more dependence on the slow, rough filtering of natural selection, only deliberate revision. But this image runs ahead of current reality. Human development is extraordinarily complex. Most traits of interest are influenced by many genes and by developmental environment in ways not easily predicted. Off-target effects, unintended consequences, ethical concerns. and governance failures all remain serious obstacles. No single explanation of the future should assume a seamless transition from present medicine to fully designed humanity. The evidence and the technology are nowhere near that simple. Still, the possibility matters precisely because it changes what kind of future people imagine for the body. For most of the human story, physical evolution means adapting or failing to adapt to environments after birth. In a world of reproductive technology and genetic intervention, some aspects of the body may be influenced before birth by deliberate choice. If that becomes more common, then future human change may cease to look like classical evolution, even if inheritance remains central. Traits could spread not because they improve survival or fertility in open environments, but because institutions, markets, or parents select for them under very different values. That would not be evolution in the old sense. It would be heredity passing through design-like filters. The danger, of course, is to imagine far more control than humans are likely to possess. The body is not a simple machine assembled from independent interchangeable parts. It is a web of trade-offs. Genes that influence one trait often affect others. A change that appears beneficial in one context may create hidden costs in another. A reduced risk for one disease may increase vulnerability elsewhere. Development unfolds through interaction, timing, and complexity that still exceed confident prediction in many domains. This is one reason scholars and bioethicists remain cautious. The history of attempts to improve humanity through simplistic biological schemes is dark, arrogant, and often cruel. Popular fantasies of engineered perfection repeatedly underestimate how messy real biology is, and how dangerous social inequality becomes once biological enhancement enters the realm of aspiration and competition. Artificial environments add another layer to the future story. Human beings increasingly live in spaces where temperature, light, food, water, motion, and even sleep timing are technologically regulated. As those environments become more immersive, the body may rely ever more heavily on external systems rather than internal adaptation. Climate change may intensify this dependence in some places, pushing more people into engineered interiors or managed ecological zones. Space habitation, though still speculative for ordinary human life, extends the idea further bodies surviving in places fundamentally hostile to them through total environmental control. In such futures, physical evolution might slow in some classic local adaptive senses because culture and engineering absorb nearly all environmental pressure. Or new pressures may emerge inside those highly artificial habitats, selecting for tolerances no one now fully anticipates. The future remains uncertain because artificiality does not eliminate biology. It creates novel biologically relevant worlds. There is also the issue of inequality, which could shape future human change more than any glamorous technology. Access to assisted reproduction, screening, advanced prenatal care, enhancement tools if they ever mature, pollution-free environments, high-quality nutrition, and low-stress developmental settings is never likely to be evenly distributed. This means the future body may be sorted not only by biology and technology, but by wealth and governance. One population may live longer, grow taller, reproduce later, avoid certain diseases, and shield developing children from environmental damage. Another may remain exposed to toxins, heat, infection, chronic stress, and poor maternal care. In such a world, human physical divergence would not be a simple matter of natural adaptation. It would be structured by politics, economics, and infrastructure. Culture would not just mediate evolution, it would stratify it. Even without radical genetic engineering, this stratification is already visible in smaller ways. Better prenatal nutrition changes birth outcomes. Cleaner air changes childhood lung development. Reduced lead exposure changes cognition and behavior across a population. Access to fertility treatment changes lineage continuity. Broad vaccination changes survival. Different built environments shape obesity, movement, and metabolic health. These are not futuristic scenarios. They are present realities. They suggest that the future of human physical change may be governed less by one species-wide pathway than by unevenly distributed technological and environmental regimes. Some bodies will be buffered more than others. Some will be selected more by market conditions than by climate. Some will be filtered through clinical choice more than childhood mortality. The old universal story of physical evolution gives way to fragmented futures. What survives in the record so far suggests caution above all. It is tempting to declare that technology will replace evolution, that gene editing or reproductive control will make natural selection obsolete, that humans will finally seize the wheel of their own biology. But such claims are usually premature. The body remains too complicated, the social risks too great, the access too uneven, and the unintended consequences too unpredictable. More likely, the species is entering a mixed era in which blind evolutionary processes continue, but increasingly alongside deliberate interventions that alter who is born, who survives, and which inherited traits remain in circulation. Human change may become a hybrid process, part classical evolution, part medical buffering, part demographic shift, part cultural sorting, part technological preselection. This is why the original claim sounds both plausible and incomplete. Scientists and commentators are right to notice that the modern and future human body is no longer shaped mainly by the same raw conditions that dominated prehistory: medicine, infrastructure, reproductive technology, and artificial environments have deeply weakened some ancient filters. But weakening old filters does not mean the end of bodily change. It means that change may now be rerouted through clinics, data, environmental management, inequality, and choice. Future humans may not stop evolving physically. They may simply do so under rules their ancestors would barely recognize. And that brings the argument close to its deepest conclusion. The question is no longer whether the human body is frozen in place. It is what kind of changing creature it has become in a world where nature, culture, medicine, and technology all press on inheritance at once. To answer that, the whole story has to be gathered together: the brutal filter of prehistory, the softening power of tools, the transformation of agriculture and cities, the interruption of mortality by medicine, the outsourcing of strength to machines, the hidden pressures inside modern physiology, and the possibility that future bodies may be shaped not less than before, but differently. Only then does the original claim resolve into something clearer and stranger than it first appears. By the time the whole long arc is visible, the original claim begins to change shape. Scientists think humans stopped evolving physically. It sounds like a declaration about the end of something ancient, as though the body reached a plateau and civilization took over from there. But the deeper story suggests something less simple and more revealing. It is true that many of the most brutal pressures that once shaped human bodies openly have weakened in large parts of the world. Fewer people die from infected wounds, more infants survive, more mothers survive childbirth, cold, hunger, darkness, and distance are buffered by technology. Muscular strength and raw endurance no longer determine ordinary survival as directly as they once did. In that narrow and historically specific sense, something has changed profoundly. The old visible form of physical selection has softened. Yet softened is not ended. and that distinction matters. Human evolution never depended only on the most dramatic filters. It was never merely a story of the strong surviving and the weak disappearing under open skies. It always involved inherited variation meeting a particular world, and that world has never stood still. When prehistoric climates and pathogens shaped the body directly, the process looked legible in a brutal way. When fire, clothing, and shelter intervened, the process changed. When agriculture narrowed diet, increased fertility, and intensified disease, it changed again. When cities concentrated waste, labor, hierarchy, and infection, it changed again. When medicine interrupted childbirth mortality, bacterial death, and childhood loss, the whole surface of the problem changed once more. The pattern running through all of it is not cessation, it is transformation. That may be the most important conclusion of all. Humans did not stop evolving physically. They became a species whose physical evolution is harder to recognize because culture began altering the environment faster and more thoroughly than in the past. The body is still there at the center of the story, still vulnerable, still inherited, still entering the world through birth and the passage of generations. But it now lives inside layers of support, risk, information, and intervention that blur the once clear line between body and environment. A modern body survives partly because hospitals exist, because clean water exists, because transportation, heating, cooling, fertility treatment, dentistry, vaccines, antibiotics, and food distribution systems exist. That body also suffers in new ways because processed food, pollution, sedentary work, chronic stress, artificial light, delayed parenthood, and endocrine-disrupting chemicals exist. The environment acting on the body is no longer simply landscape, it is civilization. This is why the claim remains so attractive. On the surface, the body looks strangely unchanged. A human from thousands of years ago would still be recognizably human today. There are no obvious new limbs, no dramatic species-wide anatomical reinvention, no unmistakable visual marker that modern genes have rewritten the form from the outside in. Many of the strongest changes seem to happen around the body rather than within it, but this visual continuity can mislead. Evolution is not required to produce spectacular new silhouettes. It can alter frequencies, susceptibilities, tolerances, immune responses, metabolic tendencies, fertility patterns, and developmental outcomes without ever creating a form so striking that ordinary people would notice it at a glance. The quietness of change is not evidence that no change exists. There is also a deeper error hidden in the idea of stopping. It assumes there could be such a thing as a finished human body, a final version so successful that evolution simply has no more work to do. But evolution does not work toward completion. It works through temporary accommodations. Every body is a set of compromises that happens to function well enough in one range of environments and poorly in others. The human pelvis is good enough for upright walking and often barely good enough for childbirth. The spine is good enough for movement and often poor at enduring modern habits. Appetite systems are good enough for scarcity and often maladapted to abundance. The immune system is good enough to defend life and often capable of damaging the body it protects. Teeth, knees, circadian rhythms, vision, and metabolism all tell the same story. The human body is not a polished, finished artifact. It is an inheritance full of trade-offs. What changes in the modern age is not that trade-offs vanish, but that society becomes able to buffer their consequences. A mismatch that would once have killed may now be corrected. A defect in vision becomes eyeglasses. A dangerous labor becomes a surgical birth. A vulnerable infant becomes a neonatal patient. A broken joint becomes a replacement, an infection becomes a course of antibiotics. These interventions are among the species' greatest achievements. They are not evidence against evolution, but evidence of how humans modify the selective world around themselves. The body does not stop being physical because help arrives. It enters a new physical reality in which survival depends increasingly on systems beyond the skin. At the same time, those same systems generate new forms of selection and new forms of suffering. Modern food environments reshape metabolism. Pollution presses on lungs, hormones, fertility, and development. Artificial light and digital life alter sleep and biological timing. Reproductive technology changes who can have children and when. Partner choice unfolds through cities, education systems, social media, labour markets, and medical buffering rather than through older local constraints alone. Migration and intermarriage reshape the flow of inherited variation on a global scale. Genetic screening and reproductive intervention hint at futures in which some traits may be filtered before birth. None of these forces make biology irrelevant. They make biology inseparable from the worlds humans build. Scholars still debate many details, and rightly so. The evidence remains incomplete on how strong present-day selection is on specific traits, on which modern burdens act mainly through plasticity rather than gene frequency change, and on how future technologies may alter the process further. In some domains, what appears to be evolution may really be development under new conditions. In others, genuine genetic change may be occurring too slowly or too diffusely to detect easily yet. Some modern ailments emerge after the main reproductive years and may therefore matter little to long-term selection. Others affect fertility, pregnancy, or child survival more directly. No single explanation fully accounts for the modern human body because the modern human environment is not one environment. It is a layered and unequal mosaic of medicine, privilege, deprivation, invention, exposure, and choice. So what does it really mean to say humans may have stopped evolving physically at best? It means that the older, harsher, more visible forms of physical selection have weakened in many populations, especially where medicine and infrastructure are strong. It means that raw bodily robustness no longer decides ordinary survival as clearly as it once did. It means the body is shielded by culture so effectively that physical change becomes less obvious and less dramatic to the casual eye. But if the claim is taken literally, if it means that inherited bodily change has ceased, that selection no longer operates, that human biology has become static, then it does not hold. The body is still in motion, though often quietly. It is still being shaped, though by forces different from those that shaped the first humans around their fires. Perhaps the most honest conclusion is that the species has not escaped evolution but changed its medium. Ancient humans evolved in direct conversation with landscape, cold, prey, parasites, and exposure. Modern humans evolve, where they do, in conversation with agriculture's legacy, urban density, medicine, fertility patterns, food systems, pollutants, machines, institutions, and increasingly with deliberate technological intervention. The body is no less real for this. It is more entangled. That entanglement makes the process feel ambiguous. It also makes it deeply human. No other species has transformed its own selective world so thoroughly while remaining bound to inheritance all the same. And that may be why the question lingers so powerfully. It is not really asking whether genes still change. It is asking something larger and more personal. Have humans become creatures carried more by what they build than by what they are? Has civilization finally outpaced the body that made it? The answer, for now, seems to be both yes and no. Yes, because culture, technology, and medicine now bear a stunning share of the burden once placed directly on flesh. No, because flesh still lives underneath all of it, aging, reproducing, suffering, adapting, and passing itself forward in bodies that are no more final than the worlds that surround them. So the story does not end with a stopped evolution. It ends with a hidden one, quieter than before, diffused across systems, and perhaps moving toward futures that will look less like classical adaptation and more like a negotiation between biology and design. The human body has not become still. It has become difficult to read. And perhaps that is the true modern mystery, not that humans stop changing, but that they change the conditions of change so completely that they can no longer easily see themselves in motion.